you all for being here. We are really happy to present today the final result of the project, a project that has started back in 2019, and it's named Culturally. We will see later why this name, because actually the project is on plus energy houses, so plus energy multifamily residential buildings, and it was financed by the Horizon 2020 program. I am Anna Maria Belleri from Eurac Research, and I'm the project coordinator. The idea of the call from the European Commission was to make plus energy building the new standard and make it viable, economically speaking. So the path from the first plus energy houses, which were single family houses, towards having big multifamily residential buildings has been quite long, and these projects aimed at building demonstration cases in different European climate to demonstrate the concept of plus energy buildings and create first pilot cases as examples for new building constructions. So the overall objective of the project was to define viable, tailorable technology concepts and business cases for this kind of building. And we believe that a successful implementation could not neglect the cultural and social aspects and their peculiarities along the different contexts in Europe. So we built up a partnership. There were 17 partners. All partners are represented here today, so you can find them in the public, and we'll present later on also the results. The partnership is a mix between RTD partners, companies providing technologies and developing technologies, and demo owners supported by local research institutions for the implementation of the technologies in the demo cases. Why plus energy buildings or positive energy buildings? They are a step forward, zero emission building, because they are buildings that have low emission, high energy efficiency, and on top of that, they shall produce more than they consume to help at district level compensate the buildings where the zero target could not be reached for many reasons, and also they shall contribute to reduce the stress on the energy grid by trying to reduce the peak demands. So we had in the project, we built the project upon 4 main pillars, which is first put users at the center, then define viable technology concept, and integrate this climate and cultural approach, and try to propose business models that make this concept viable. And so we started first to understand the climate and cultural differences around Europe, develop key technologies which are coordinated by a cloud-based house management system, and then develop fact sheets and guidelines on how to integrate these technologies into the buildings and demonstrate them in the 4 demo cases. Our demo cases are representing not only different climate and cultural context, but also different kind of ownership and models of the building. So we have private real estate, private social housing, public buildings, and private cooperatives, so that we could also look at business models from different perspectives. The main project highlights, which will be presented today, includes these 4 technologies developed, 4 demonstration cases. We will have in the afternoon a discussion on policy recommendations that we defined, and I'll be presented right after this introduction the design guidelines for PEBs, which include an overall performance evaluation, not only from the energy and perspective, but also from economic and environmental impact perspective, guidelines for business models, guidelines to assess the co-benefits of plus energy buildings, and then also later on the colleagues will be presenting the PEB Hub, which is web platform aimed at creating a community for designers on plus energy buildings. So I'll be going straight to the point. So design guidelines for plus energy buildings. They are so what is, let's start first to define a plus energy building. That's how we started in the project, what we need from a plus energy building. We need it to be very, very efficient, and so exploiting all the bioclimatic design rules and trying to reduce the energy consumption as much as possible. The overall evaluation of a plus energy building shall include all building energy uses, including plug loads and appliances, in order to be able to really ensure that the surplus energy can be shared and sold outside of the building lot, let's say. Also, we name it plus instead of positive only because we also wanted to highlight other advantages that plus energy buildings have, such as a good match between the energy consumption and production in order to ensure flexibility of the building, to have low greenhouse gas emission, and to ensure an added value for the users, so with an accessible, comfortable, and healthy indoor environment. And also facilitate the access to e-mobility. There are, in our opinion, 7 key design principles, and you can find from the QR code here a preview of the design guidelines that we developed and are based on these key principles. First, they should create indoor spaces easy to access, comfortable and healthy, align building design technologies and configuration with the residents' needs, produce more energy than use, optimize the use and store of renewable energy, building flexibility to maximize energy self-sufficiency, minimize greenhouse gas emission, and keep affordable costs over the building life cycle. So how we did that? We started listening to residents' voice. We will have a nice presentation later on how we applied a social practice-based approach to the project. First, starting with interviewing tenants from low-energy buildings to understand what are their practices and how they might create conflicts with energy consumption. And starting from this to try to incorporate or suggest trade-offs in the design in order to consume less energy, but still meeting the tenants' needs. Then we found out that comfort is not just about keeping temperature inside the specific ranges, because it's a complex mix of user preferences, habits, culture, and other social aspects. A study made by the colleagues from the University of Venice on an existing database show that users in different countries respond differently to different indoor temperature scenarios, and they might prefer higher or lower temperatures depending on also what they are used to, and also depending on which is the level of air velocity inside the environment. So the higher the air velocity, the higher is the temperature that they can accept, and there is there are quite significant differences between the southern European countries compared to the northern European countries. Then the energy production. So we look at also maximizing the energy self-consumption of the building. First of all, to reduce the impact of the building on the grid, and also because it seems to be the cheapest way to exploit it, since the energy surplus is not that incentivized so far. And so you can see from the graph, the self-consumed energy is meant to be the energy that is generated on site by, for example, PV installation, and is directly or instantaneously consumed by the building itself. And that's easy to say, but it requires a lot of work during the design phase in order to ensure that this is possible. In the guidelines, you can find also fact sheets that report the solution set that we analyze, and by solution set we mean a mix of different technologies, from building envelope characteristics up to HVAC system and PV and battery sizing. We analyzed the performance of this solution set in two building archetypes that more or less cover the typical typologies of multifamily residential buildings. So a high-rise building, very compact, and a low-rise building is just a free floor with 3 floors and developed on the floor plan. And we tested them in 4 different climates. And the fact sheets also reports not only energy performance in terms of primary energy consumption, final energy, and self-consumption and generation, but also reports the life cycle assessment of the solution and the economic impact in terms of cost of investment and the total annual cost, which includes also maintenance cost and the revenues due to the selling of the PV energy, so up to the overall life cycle. Also the fact sheets reports some hints from the findings that we got from the interviews with the residents, trying to provide also a perspective on the social aspects that we might encounter in that specific context. So, as we report here a sort of summary of one of the solution sets analysis, as we can see in the graph, the majority or almost half of the consumption is due to appliances and plug loads, which is something that has been so far neglected in building energy performance evaluation, but if we want to still be able to produce more energy than we consume, then we need to also find solution to reduce that share of energy due to the plug loads and the appliances. The balance, so the overall positive balance is sometimes not reached because we also trying to find to balance with the economic and the environmental impact aspects. So of course meeting a positive energy balance is easy if you put more PV on your roof or other spaces in the surrounding of the building, but this is an additional cost and also an additional impact on the environment. So we tried also to optimize that, considering also that the buildings are equipped with batteries that can store part of the energy produced on site. So as example, in this graph, you can see for each climate context and for the two different building typologies that we look at, which is the share of energy that can be self-consumed on site, and which is the energy that is imported from the grid. So we especially in the Mediterranean climate, we reached up to 70% of self-sufficiency rates, while in other climate where the renewable energy production is not that efficient, we reached up to 40%. We also look at the environmental payback of the technology solution, so which is the environmental payback is the time, is the period that when the building pay off his greenhouse gas emission and offset his greenhouse gas emission thanks to the production of renewable energy. And in the Italian and German context, we reach the environmental payback by 2050, assuming that the the building construction ended in 2024. While in the French and the Norwegian context, the payback period are quite longer because the carbon intensity on the national electricity grid is lower compared to Italy and Germany. So there's a high share of renewable energy in the grid itself. So they are not being paid off, environmentally speaking, let's say. We also look at the cost compared to a nearly zero energy building scenario. There is a difference between 200, 300 euro per meter square in terms of investment cost. And we found out that the profit of the investment really depends on how the surplus electricity is used. The best case scenario is when the building manages to sell the energy to the neighborhood or to the neighbor at so directly to the neighbors, offering that at a lower tariff compared to the standard tariff of the grid, in order to make it attractive for them. And therefore, in this context, it is still, so without this incentive, it would be more profitable to self-consume the energy produced as much as possible. And finally, we are also supporting the demo owners in preparing home guides for the tenants, starting from the social based practice approach, and following up with a post-occupancy evaluation of the building. And the design guidelines also include the toolkit useful to support that. So I will quickly conclude with some key messages based on the experience of this project. So social, cultural practices and residents' needs really proved to be helpful to shift towards user-centric design. We identified multiple strategies to reach the positive energy balance, and it is key to optimize PV installations, but also to reduce the appliance-related energy demand. Plus energy buildings can play a significant role in reducing the stress on the grid with up to 70% self-consumption rate. And dynamic building operation is also a key to shift the energy uses in time in order to manage better the on-site generation use, and to minimize the operational cost of the building. And life cycle assessment should be applied within the decision-making process to promote sustainable choices in terms of building solutions. So, yeah, please find more details in the design guidelines online. As I mentioned at the beginning, there's a preview version now, which will be finalized by the next month, because we are closing the project. And thank you, everyone. I don't think we have time for questions, or we'll skip directly to the next presentation. Then there will be a panel discussion where we can open up to questions. I leave the floor to Beatriz Pineda from RMIT Europe, so one of our partners, and who worked on the social practice-based approach. And please, Beatriz.
Thank you, Ana Maria. And good morning, everyone. Can you hear me well? Yeah, great. So my name, as Ana Maria was saying, is Beatriz Pineda. I'm a research fellow at RMIT Europe. For those who don't know, RMIT Europe is the innovation lab of the Australian University, RMIT. We are based in Barcelona. And we've been the social science and humanities partner in this project. My presentation has two parts, so I will start introducing a bit more this approach, this social practice-based approach to Plus Energy Building design, and I will finalize the presentation presenting the Plus Energy Building Hub, the repository that we've been working hardly this last year, so we are very happy to be able to present it today here to you. So without further ado, yeah. So we've been in Culturally conducting semi-structured interviews with residents living in highly energy efficient buildings. And I want to share with you one of the main findings, right, that we got from these interviews. So in all 4 geoclusters, in all 4 regions that we analyzed, so residents were overriding the technologies when their needs were not fulfilled, even if they knew how to operate the technologies properly, and even if they were aware of the consequences, right, of their actions, so the energy bills going up and so on and so forth. So this is quite a symptomatic finding that proves that, behavioral approaches, right, are not working as expected. Basically, so many of you might know that behavioral approaches are based on providing rewards, providing incentives, right, like this carrot and stick image you see here. They are, nudging people. They are trying to punish you if you do the wrong thing, giving you like some monetary incentives if you do the right thing. And basically, they are assuming a lot residents' motivation. So we tend to think that people are motivated by economic incentives, while research has been showing that these economic incentives are very intertwined with other motivations, such as the will to behave in an environmental friendly way, or self-fulfillment motivations, and many others that we don't have time to cover here today. Basically, they treat people, right, as rational beings. So assuming that if you provide them with the right information, they will change their behavior and they will follow, right, what is expected from them. So further from reality, as our project has been showing, so residents tend not to read manuals. And so if we expect to give them a manual and actually them changing their behavior, we are a bit far off. So basically, in Culturally, we've been applying a different approach, coming more from sociology instead of from psychology, which is the social practice-based approach. I don't have that much time to explain this in detail today, so I will be brief. But basically, this focuses not on changing individual behaviors, but on shaping the social practices, right, that residents perform in their homes daily. This being heating, cooling, ventilating, cooking, sleeping, cleaning, you name it. So all the things that we as residents tend to do in our daily lives. And what we've been doing is to see how some of these practices are conflicting with each other, right? Decreasing and affecting the energy efficiency in these buildings. So I'll show you now 4 examples of these conflicting practices, because I want to illustrate, right? I want you to be in the mindset of a designer. So how many of you are designers here today? I know some are here. Any other architects? You were here, yeah? Okay, so I want you to go, and I'm myself also an architect as well. So I want you to go through this journey with me. So basically, when we think of this practice, right? So taking care of a loved one. So if you have a newborn, if you have a sick relative, if you have visitors coming to visit you, right? So you adjust the way you act in your home, right? You might add extra heating. So at the core of these conflicts in the practices are residents' needs. And these residents are something that we all want to fulfill, no matter what. We become very creative. We override the technologies in order to get what we want, right? So when we talk to the residents, you can see here some of the quotes that we were compiling. So there were like these practices of care, right, at the core of these needs. Some of the interviewees were talking about kids with allergies, like asthma, this type of needs that sometimes make you interact with technologies in a different way. It might make you open your windows more often or less often, or raise the thermostat, adding extra heating. So these are all practices that, when we talk about behavior, we tend to put users into categories, like we profile users, and we don't realize that the same person, when the circumstances change, might act differently. So this is at the core of this sociological approach, right? We don't put people in boxes, we think about what they do, and we see how we can work with that. So another example of these conflicting practices is this need of being in contact with the outdoor space. So basically, to hear nature, to hear the birds, these were words that were used by the residents, and the windows, right? This need to opening windows, not just for ventilating, but for being in contact with the outdoors. So this is something that was happening and that was present in most of the geoclusters that we cover. And as you see, so the need is to feel this contact with the outdoor space, to hear nature, and the response was to open windows longer than expected, right? Longer than what you should be doing in this type of buildings. So these two first practices appear in most of the geoclusters. In contrast with the ones that I'm about to show you now, that come from our dear Norwegian partners. So sleeping at an adequate temperature, right? And having like these crack open windows, so windows that are not fully open, but are just slightly open, right? And this also relates to having the appropriate duvets. So in Norwegian, they call it like dyne. Is that correct, the way it's pronounced? So we learn from them that actually the way bedrooms are designed, they have like a lower ceilings, so basically the amount of air available at night is less, and in traditional buildings, the only source of fresh air was to open the windows. So people have been growing up with these habits, right? These ways of, you see your grandmother having the window open at night. So basically, you do that, right? And then you keep on having like these reinforcing practices. So this was somehow related to this ability that Norwegians have to have the right clothes, the right duvets, so they are not afraid to sleep with their windows open even if it's below 20 degrees Celsius outside. So this is something that someone in Italy might not consider, but a designer in Norway should keep in mind, right, when they design their bedrooms and these buildings. And the last example of conflicting practices is this one, right? So we were talking to the residents and to the staff members in the Norwegian demo, and they were telling us that some of the residents were feeling cold. And even if the floor heating was supposed to provide, for a good thermal comfort, they were adding these electric heaters. And if you go deeper into these conversations during these interviews, then you realize that they come up with these childhood memories of having an open fireplace, and how they have like this idea of, they miss this direct warm source. And they were adding that because they were maybe reminded of how they grew up. So these are just a few examples that we've been collecting out of the many. So if you are interested, you can go through our deliverables and see many of these. I would love to tell you more here. But this is just to illustrate that some of these residents' needs are coming, out of our human biology. So the first ones that I was referring to, this need to be in contact with outer space, this care for loved ones, this is something that was repeating in all geoclusters. So there are different types of residence needs. The first ones are common to all of us because of our human conditions, but there are others that are more shaped and influenced by the climatic and the sociocultural factors. And designers should keep both in mind, right? And they should acknowledge that they will have, users, residents will have different preferences. So this is just to give you a taste of what we've been doing as part of this working culturally. And we came up with kind of an easy, straightforward approach, right, to apply practice theory to design of plus energy buildings. And we would like designers to reflect right on these potential conflicting practices. And instead of thinking of behavior and how to nudge people to do the right thing, it's about understanding what they already do and try to anticipate, right? When you anticipate your residents' needs, you are more able to design for them in a way. So it's kind of like moving both ways towards each other. And so if you identify these residents' needs that are at the root of these conflicting practices, and then you also are able to realize how they respond, how these strategies that they apply, you will be, better off thinking of these design trade-offs and having, if possible, feedback during the design process from your residents or from people who can provide you feedback of these technologies and adjust during the process. That would be even better. I know that it might be a bit in an ideal world, but this is some of our recommendations. And I'll go, because I think we don't have much time, right? I'll go to the second part of the presentation, which is also very much related. So this Plus Energy Building community repository that we've been building, it aims to become like a source of information for PEP professionals, so not only designers, like architects, engineers, but also researchers and other like technology providers. I know that we have some of you in the room as well. So we've been very hard working on this, EURAC, RMIT, ACE colleagues, and you can access through the QR code. I invite you all to go and check this. I'll do this live tour now through the platform. So let me go for it. And yeah, and so, and the mouse, Marta, might be just here, right? I just do it like this. So this is how it looks. This is our Plus Energy Building Hub. This is part to tell you of a platform that EURAC is designing of highly energy efficient buildings. So you will be able to go to the Plus Energy Building if you click here. So this has different tabs, as you see. In this Plus Energy Building, oh, no, not like that. Okay, here we are. So in this first tab, you see like different real-world examples of Plus Energy buildings. At the moment, we only have input 4 of them, our 4 demo cases. And if you click on one of them, for example, the German one, you will be able to see the name of the PEP, construction year, climatic zone, who was the architect, our beloved Ringo, who is not here today with us, but Herman is the engineer who has been supporting. So owner, a small description, then like some numbers about the building area, net area, gross area, different relevant data for designers, some photos, and then you will have like different tabs. So what are the solution sets that have been applied regarding to heating, cooling, ventilation? We'll have like another section for renewable energy production, about the building envelope, right? So what are the envelope technologies that have been applied? So you can see, okay, types of walls, different types of materials, U values, the same for the roof, the same for the windows. And then we have this section about climate and culture, right? That is so characteristic of our project. So I think this is one of the points that make the PEP Hub also stand out, because not too many other projects have been taking into account these aspects. And if you go here, you can see the questions that the designers have been answering in order to make them think of these design trade-offs that we were talking about, right? And within the Plus Energy Building Hub, so you can also see what Ana Maria was explaining us before. So what is a Plus Energy building? The design guidelines are here, so I can show you how they look. These are the key principles he was telling about. You can click on them, and at the end you can, of course, download the design guidelines, so it's quite straightforward. So I advise the designers in the room to go and check, and also to please, if you would like to join our community, you can get in contact with us, and we would be delighted also to showcase your project. We are, let me just go back to the presentation, which was, let me see. Oh, I put something up here. Close the window, yes. And here we are. Back. Bear with me, yes, here we are. So just the last slide from my side. So this is what I've been showing you in the PEP Hub. So we also have like a quiz that is for like a general public in order to increase awareness of Plus Energy buildings, right? So why are they important? What are the benefits? So it's quite a complete website that is been collecting actually most of the work that we've been doing in these years. This is how it's looking. This is the static version of what I was showing you. And to finalize, so I would like you to be warmly invited to this webinar on the 18th of March. We'll be officially presenting the PEP Hub. So in this, in the meantime, we will be populating it with the PEP cases that we've been receiving from many designers. So you will be able to see like how it's actually looking, right? So please register and join us. And to the designers in the room, you can contact us via the website, or you can also send me an email here. Thank you very much. Mm-hmm.
Thank you, Beatrice. Yeah. I think we can leave this slide, because now I would like to call some of the partners of the project on the stage to run the panel discussion on design challenges and opportunities for PEB. So please come here. So I got the pleasure to have a great partnership in the project, and now we are having on the stage, one chair is missing. Thank you. The partners who have been working on analyzing and studying the different aspects of PEB. And so let's start first with a quick round of presentation. Please just your name and the expertise you brought into the project.
Good morning, everyone. My name is Wilmer Pasut. I'm a professor of building physics at the University of Venice, and I brought to the project the perspective of users and their way they perceive the indoor environment and interact with the system in the indoor environment.
I'll be quick. Oh. And so I'll be quick because I just talk. So just to maybe add to what I explained before. So my background, I'm a researcher, both an architect and sociologist. So today I had the hat of the sociologist here. And yeah, I'm happy to discuss further. Yes.
Yeah, hi everyone. My name is Francesco Zaia. I'm a researcher at URAC. I'm a building engineer with a PhD in energy, and what I did in the project was mostly related to doing building energy simulations and try to bring together metrics from the energy simulation, but also connecting with the work of Herman and Roberta, which we'll talk later about life cycle assessment and life cost assessment. So we brought everything together. And yeah, so that was my role in Culturally.
Good morning, Antoine Duguet. So I'm French, coming from Nobatec, which is a research technical organization. And similar to Francesco and others, so rather an energy background and working on energy engineering applied to buildings. And they are connecting more or less the considerations on design and technologies in this project.
So good morning, everybody. My name is Hermann Leis, coming from SEZ Energy Plus in Stuttgart, located in Germany. So my experience is in making simulations on building design, so in the field of plus energy building, and we have a look also on the thermal comfort inside. But why I'm sitting here today, this is another reason. So it is because we did some economical analysis and a life cycle analysis of the plus energy buildings. So, thanks.
Hi, hello everybody. I'm Roberta Di Bari from the University of Stuttgart. I did my doctoral research at the University of Stuttgart, and I worked also in Cultural Ill project. I was mainly responsible of life cycle assessment of Cultural E technology, so all the novel heat pump, air ventilation system and windows system that have been developed in the project. I also carry out the analysis and LCA analysis for the Cultural E solution set, and finally for the demo cases.
Okay, thank you. So, yeah, just to break the ice, I will start from the social practice-based approach that we just saw, since we just saw the nice presentation of Beatrice. So, question for her will be how to put this in practice into the building design.
Thank you. So I might repeat myself a bit. So I think the tip that we have for designers here is to have these 4 steps in mind, right? So to have like this idea of understanding what are these conflicting practices that might be happening within your future buildings, right? To take into account what are the residents' needs at the root of those practices, and to anticipate how they will respond to those, in order to fulfill their needs, they will do something, right? They will have like different strategies, different responses. So the more you anticipate yourself to those responses, the better you will be able to have like these design trade-offs in your plus energy buildings. And since these are quite novel buildings and technologies, so we recommend you to have direct contact with possible residents so that you get feedback also during the design phase. Yes, thank you. Brief.
Okay, thank you. And how can we work on building technologies in order to, how can we tackle this approach to building technologies?
Yeah, I think this is a challenge because normally technology providers or technology designers are detached from the users that will be using those technologies. So I think it requires an effort from both sides to bridge this distance, right? And to be able to position yourself in the shoes of a user, and as much as possible, as I said, if you have this possibility to have like different focus groups with potential users, or to experiment, right? Like have pilots, tryouts. So I think that would be a way to bridge this gap.
Yeah, and speaking about technologies, Antoine worked on the technology integration, followed the technology developments and the implementation in the demo cases. So let's start first with understanding what does a PEB need in terms of technologies.
The first comment that we can make is that the context is changing. So yeah, we're looking at rather high performance building, and the designs were, let's say, made by mainly by architects, and then so the technologies come in this context where, I mean, for example, we often think about the heating, but it comes like third in the ranking of the most energy consuming stuff. So appliances, pluggable, for example, in one of Anna Maria graphs, it was obvious that pluggables or appliances were the most energy consuming equipment, and often come next is domestic hot water. So so we have to take into account this context of also changing habits, context of climate change, and so on. So then obviously we have to reduce energy needs, and it comes with heat recovery, it comes with high insulation, and so on. And so for the system, it's in our case, it was to use a decentralized heat pump that allowed to have both domestic hot water and heating, and ensuring the ventilation. So in this case, it was quite, the challenge was about the architectural integration rather than the technology itself. And the other comment is, it's about having a good combination of technologies, in the sense that you will have those highly innovative technologies potentially, but you have to combine that into something coherent that might differ from the German case or the French case, for example. And the last, and maybe the most important one, is about the occupants. So usages will drastically impact the energy consumption. So we have to enable those occupants, as Beatrice pointed out, and either with a carrot or with different stuff. But the idea is to how you make them behave accordingly to how it was designed. And what we chose to do is rather set it by collecting information, having communication toward the occupants, providing information. That's the key aspect, rather than controlling. It's providing, communicating, and through this data collection, providing information, and with to the occupants, the idea is to engage them towards more virtuous behavior.
Yeah, thank you, Antoine. Also, optimizing and harmonizing the technology functioning was also key in this project. And so maybe a question to Francesco is, how can we approach the building design in order to make sure that there is all the technologies installed in the building can actually work together towards lowering the energy consumption and meeting the residents' needs?
Yeah, so what we have done in the project was to approach this by a great deal of energy simulations at the beginning, and it was interesting to see we were able, let's say, to test the different technologies which were being developed within the project, also combined in different ways. So, for example, in the fact sheets that you will find also in the website, you will find two solution sets. Which are two technological solutions which are grouped in a different way, and we tried them in the different climates that are, I mean, were part of the Culturally project, but which are also representative of, let's say, more or less Europe, because we had Norway, we had Italy, France, Germany, and we found out that, of course, there is not one solution that fits all, and in each climatic condition, and also because of the cultural, let's say, aspects related to how people behave in their buildings, there were differences. And it was interesting, I mean, we knew that there were differences, but it was interesting to quantify those differences and to understand which solution sets could fit better in a climate or in a cultural context. So that, I think, it's, I mean, the approach we use, which is quite useful, and I'm happy that we were able also to have these fact sheets which are available for everyone, and also the underlying energy models that we used are also available. So anyone can download these energy models and anyone can use it. They are quite straightforward. So we transformed a complex energy model, which is really usually, I mean, run by an expert who only does that. But in this case, these energy models are transformed in a file, in an executable file, which anyone can just open, change some parameters and run simulations to see what changes by changing some conditions and parameters. So I think this is also an interesting outcome.
And what about the control of the technologies?
Yeah,
tell us more about
there
it?
was also a key point, a very interesting point, because we saw that if every single technology by itself is controlled in the best possible way, but as standalone, then the system as a whole doesn't behave as well as by combining these technologies together and controlling them through, let's say, a holistic approach, so taking into account everything at once. Because sometimes the different technologies can act in ways in which they are, let's say, I mean, putting the other technology to work in a worse condition than it should be. So instead of going in the same direction, they are doing things which are in contrast with each other. So what we have pushed to do is to design a control strategy which was harmonizing, let's say, in a way, all the technologies so that everything worked well together and not in the best way, theoretically, as a standalone system.
Yeah. And yeah, so as you might have get, PEBs are quite high-tech buildings, but yeah, what or how do we expect the users to have a role in these buildings? Wilmer, can you tell us how can we, how do users influence the energy performance and the use of the technology, and yeah, what are their expectations towards them?
Yeah, thank you. So, as you may guess, already by the name of this project, Culturally, really the focus is the user instead of the technology. So, we dealt with technologies, but always in relation to the user. So the idea was to try to conceive a project that was a bit different to what we saw before. We were thinking about we need to work first to try to understand the users and then propose something that works for the user, for the cultural habits, for the way they behave, for the way they interact with the house, with the system, and then we can make a plus energy buildings. Because always when you think about plus energy buildings, it's always a balance, it's a scale. So what you produce and what you consume. And what you produce is dictated, of course, by the presence of photovoltaics, and that's the easiest part. Is you put more or put less, and then you have already an idea how much you can produce. But what you consume there is the difficult part, because you can work with technologies to reduce the consumption, but then there is the user. And the user really makes the difference, really, really makes the difference. So that's the point of this project. We notice that there are some trends among users. So there are strong differences between one country and another in terms of energy consumption, which means differences in terms of expectation toward their environment. Different expectation means different in their conditions, and so different consumptions. This is what we notice and what we saw and what we prove, actually, analyzing some some big databases that we have in Europe coming from previous projects. And the idea is really, if we know from the design phase that there are these differences and we know how much are these differences, we can work around that and make them something that we can make a design that works with those differences to make something that is at the end really a plus energy building. We are seeing right now these tendencies to have the range of these dangerous tendencies, to have the range of winter indoor temperature and summer indoor temperature that start to overlap, and which is quite bad. It makes me think about the song that says comfortably numbed. So people, they are just comfortably numb. They don't perceive, we are moving toward an indoor environment that don't provide any perception. We are moving toward this situation. So the idea here is really to try to understand what's going on and try to provide solution technologies that are respectful of the user perception of the environment, trying to give the best, a good indoor environment while saving as much energy as possible to try really to achieve these plus energy results that we want to achieve.
Thank you, Wilmer. So yeah, now we look at the optimization of performance from both building and user side. But now the question is this economically viable? Does the investment, the extra investment pays off, Herman, based on your LCC analysis?
So that's an interesting question. So we heard a lot about technologies and what is needed and about the needs of the people and so on. And so economics is a wild field, as everybody knows. And it is clear that some extra technologies causes some extra costs, that's clear. So for production of electricity, we need photovoltaic elements, and we add a battery. And then we have some other extra costs, which is due to the house management system is a keyword in this context, where all the team was also working a lot. And to look to the economics, we did a LCC analysis, which means we had a time horizon of about 30 years. And it's important to take into account three big types of costs. So first one is the capital cost, which is mainly investment. And then we have the maintenance cost, and we have the energy cost. So in these three parts, you see there are three crucial points. One is the first investment. So we have more investment. This is for plus energy building, we learned that it is about 5 to 10% more investment, initial investment. And second point is the lifespan of the techniques we have. For example, a battery at the moment has a lifespan of 10 years, so we have to replace it 2 times in 30 years horizon. And in the same time, in other technologies like heat pumps, we have the same thing. So at the moment, we calculate about 15 years lifespan. So, and this takes also has an influence in the economic viability of the projects. And we have those more costs, and we can get the money back due to the fact that we don't have to sell that much energy from outside because we produce our own energy. And in this context, there are 2 important points. So, and these points are very different in each country. So this is the regulation boundary conditions we have for the people who tries to sell the electricity, for example, to the tenants. This would be the most interesting. This is one thing, and the other point is how much does it cost to produce the electricity itself. So we have the example in Germany. We come up to a situation where we are quite at the limits that we can get back the money in the 30 years. But in the Italian case, it's quite different. And there are reasons for that. So one reason is in Germany we have a high electricity price, and due to the fact in the demo case we had a big, simple installation surface for the photovoltaic. So the photovoltaic power production was cheaper. Then in the Italian case, where it was a decentralized system with photovoltaics and a battery system. And on the other hand, the electricity cost in Italy is much lower than in Germany. So this leads to the different economic situation. So maybe I can conclude something, what would be interesting in future. So one thing is at the moment is in the right direction. So this is because the prices of photovoltaics went down also for the batteries. So, and then second one would be maybe to increase the lifespan of the technologies installed in the buildings. So I think this would be the main things to do in the future.
Yeah, because so far the lifespan of technology is on average 15 years, right? Am I wrong? Or
It's depending on
technology.
so if you look to the standards, then they have a lifespan, for example, for also for the piping and so on. But we did not change the piping systems because in practice nobody does it. So after 15 or 20 years, nobody does change the piping, and also the ducting are not changed in 15 years. So we did not change it in our calculation also.
Yeah, thank
Because we would like to be realistic.
Yeah, as we.
Okay, thank you.
Thank you, Herman. And latest aspects. We have worked on new construction, and therefore we couldn't neglect to look at the environmental impact of this building and check whether they can pay back their emissions over their life cycle. So Roberta analyzed this aspect. So what is the impact of these buildings?
Well, as you are aware, there is a great conversation at the moment regarding embodied impacts against the operational impact. And of course, we are designing plus energy buildings to reduce operational impact and therefore based on improvements of the operational energy of buildings. But what was like the elephant in the room in this case were exactly the embodied impact. As for Herman, that was talking about capital cost, investment cost. We have to think about that embodied impact, so all the impact that are due to the production stage, maintenance, any replacement, and the end of life of our product. These are investments, and these are normally not, they are not positive investment because of course we are causing greenhouse gases emission, and this is also leading to harm our climate and our planet. So we need to control embodied impact. This is the first task that we must do while we should analyze technologies, the solution set, so the technical equipment of the buildings and the building itself as a whole. So when we were looking at the solution set, what also Anna Maria showed previously is that we are producing on an average of 2 kilograms CO2 emissions per square meter per year. And this value can be paid back in 30 years. This because there is the photovoltaic, there is producing energy, and there are energy credits which can be converted also in environmental credits. So we are paying back the initial investment. But this happens only in a context like the Italian and the German context, where let's say that photovoltaics are also plus energy buildings and related system can really boost the transition towards renewable energy. So we are improving both the energy, the national energy mix, and we are even paying back our initial environmental investment, let's say so. While for other contexts, like and like in France or in Norway, we have different baseline of the energy mix. So perhaps they are not really looking for renewable energy, or let's say they do not need to improve the carbon footprint of the energy mix with the energy sources that they are already using, but they can anyway use plus energy buildings or solution set aim at plus energy buildings to make the buildings independent. So they can have advantages that are limited on the building themselves. So in other words, the user is able will not need to purchase energy from the grid because the building is independent. And so this is the first lesson learned. But when we are looking at the investment itself, let's try to improve, to optimize, and to reduce, when possible, our investment. 90% of the 2 kilograms CO2 emission are coming from photovoltaics. So at the moment, the photovoltaics, it is a solution for the production of renewable energy sources. We are not discussing that, but we need also to improve the way that photovoltaics is produced at the moment. So it is really requiring the future to identify improvement and like way to enhance or to make this technology also climate friendly, starting from their own production and their end of life. Yes. Oh, okay. We are talking about light and shadows of solution set and plus energy buildings. We need really to be aware of them. When we are looking at the whole building as a whole, we can say that the technical equipment, so the solution set, is responsible of.
I think it's not working. I can give you.
Yeah, so the technical equipment is responsible of about 16% of the total embodied impact of the building, which is good news. But let's see also the shadow, the greater amount of embodied impact. So impacts due to production and end of life are coming from other building parts, the structural elements, the insulation. So what the designer must be, they must be really aware of the total environmental impact of each system belonging to the building, and finding also a way to reduce embodied impact of structural elements, isolation elements. Here also, Cultural A provided us some good insights coming from different demo cases, because we had the Italian demo case. In the Italian demo case, the plus energy buildings performed in terms of only embodied impact. We are talking now about that. It's performing like a reference net zero energy building. So the total impact are really similar. And then there is the case of the German demo case, like where designers were aware of the embodied impact and they made environmentally aware decision makings during the yearly design. So just for giving you like few numbers in comparison with a reference building, net zero energy building in Germany, which is around 13, 14 kilograms CO2 emission per square meter yearly. The building in Germany, the plus energy building, achieve almost 4 or 5 kilograms CO2 emission, which is 1/3. This is mostly due to the design choices, the reduction of concrete elements or any mineral-based elements, the choice of bio-based material. So this is also an insight for designers, for architects, definitely looking at the future by using a more natural-based solution, and also making sure that we are not over-consuming materials, like making also choice in terms of material optimization.
Thank you, Roberta. Yeah, that really is an interesting aspect, and we learned a lot, I think, during the project about this. Is there time for some questions from from the audience? So, yeah, please.
This is all very, very dense. I'm going to try to be really short. About 30 years ago, I spent 3 months in Siena on a building workshop with Giancarlo De Carlo, where participation, user feedback, working with, I saw the big 1970s, 80s participatory architecture. And this is really what we're getting back to. I designed this building. I don't think we could have designed it without excellent engineers, without people like you that do this kind of research. One of my questions is, in Brussels, for example, about, let's say, 65 to 75% of what is built by developers. We have worked with many, many developers. The price is the end. How much you build for per square meter becomes the most essential question. Brussels would never have gone passive if it had not been imposed. So sharing what you were doing in in around 2010, 2014, when Brussels started talking about going passive, what made the difference was sharing the information, training, information. And at a certain point, legislation changed and it became mandatory to do, not passive house, but more or less passive buildings. And it was only because it was imposed. The most important thing that really changed, though, is not really the legislation, but it's the fact that users, so the demand that developers have to respond to with what they offer on the market, the demand changed. User comfort, energy, what you spend paying your energy bills. And so really connecting with the users, I think, is one of the best ways to change what developers, and they are the ones that build our cities mostly, this is really an exception. That is something that really has to be discussed. Our first buildings had to be within 1,250 euros per square meter, otherwise it just didn't get built. This building is built at 1,400 euros per square meter. It's a particular building, particular functions, but really how much things costs, it's really, really important. Legislation costs, but users, I think, really have to become central because they're the ones that developers, people build for, have to respond to. I think that'll make a really big difference. This is so dense. I wonder how you're going to share it. I'm wondering why there are so many people, so little people at this conference. The way you communicate is going to be really, really important. It's a great job.
Thank you, Sabina, for your comment. It's very inspiring. And we are trying to disseminate as much as possible. We're not great communicators as engineers, but we are trying to do our best. We have we are lucky enough to have Ace in the project, who is our contact towards designers, and we are trying to make the most out of it. And demonstration cases are also a mean for us to get to the general public and to show users that these buildings perform, hopefully, better. So the post-occupancy evaluation will be also key, which we are doing right now, because the project has has encountered many barriers along these 5 years. So the demo case is starting now their operation. So we are in the phase of getting feedback, and this will be also valuable for communication, I think. Then other questions? Maybe do we have still time to conclude for a quick question round with the audience? Just in one word, what is the added value of PEB in your opinion?
So in my opinion, does it work? Yes. In my opinion, the added value of PEB is not really the balance of energy itself, but to try to bring the focus on the importance of the user again, because working on them is the only way to achieve a plus energy balance. Otherwise, it can be very, very difficult to do that. No matter how much photovoltaics you put on your building, it's going to be basically impossible, because we have all those effects that we know, rebound effect and so on. Then you feel like, oh, I'm producing energy, I'm going to use more, I don't care. So we need to work more on the users. We need to guide them. We need to understand their behavior and their interaction.
I agree, Wilmer. I think for me the key word is comfort. I think we need to think of the users and provide them with what they need, and make technologies that allow them to actually feel, comfortable at home. Because if not, they will override the technologies, as our project has seen. So I think for me, comfort and this direct contact with the users, taking into account their needs, is super key in all buildings, but especially in these ones where technologies might pose a barrier. So, yeah, comfort.
Yeah, to me, an important word is adaptability in this multiple sense, both in the sense of buildings able to adapt to users' needs and to be flexible enough to adapt to the needs of people staying in the buildings, but also towards, for example, the grid. So being flexible toward the grid and being adaptable in this way. So adaptability to me is a key word.
I'll try something a bit different. Like what we do also is to provide some inspiration, I would say. So because PEBs at the moment are not so numerous, and maybe in the future not the typical buildings, but by showing that it's feasible, that we can deliver such building with comfort, with adaptability, it can also lead to new approach to design, and so it's also something to consider.
It's difficult to say in one word. So for me, the comfort is not the main thing, because in a standard new building we have also high comfort, but the plus energy building that gives me, that shows everybody that the energy is not coming from somewhere, but this is coming from, it can be a local resource, and we cannot use energy like we want. So because this has a big impact, and that's a main thing.
Yeah, I can use my microphone. Yeah, I definitely won't say, even if I would be the responsible environmental sustainability, I will not say in one word sustainability, not because I have something, I would like to show only the shadows, or I discussed about the shadows, but mostly because sustainability is a really complex word. It is hard to say what is actually sustainable and what it's not. We need to have a big picture of the whole, of the whole impacts that are caused by buildings and plus energy buildings in this case. But definitely, I will use the terms of quality and especially environmental quality, like plus energy buildings, the way that are conceived, especially as being conceptualized and conceived in Cultural A, they have all the features to ensure quality in an holistic way. So from the thermal comfort, from the user comfort, also even from the environmental quality point of view. But everything depends on the choices that are made by users and then, of course, designers.
Yeah, so many different ideas, but I think all have are valuable. And so, in the end, this project aimed at increasing in Europe the share of PEB. So, how is the way, in your opinion?
So, for me, let me start to to answer you from this point. So if you think about designers now, architects, I think that the work of an architect has never been so difficult and so easy as now. Because if you want to design a building and make it comfortable, you can make a very ugly and simple building and just put a bunch of technology and it's going to be comfortable inside. But you're going to use a lot of energy. It's going to be comfortable. So that's the easy way to be a designer. On the other side, if you want to really do your job as a designer, you need to take into account that the population is changing, the habits of the people is changing, the climate is changing. You need to reconceive the design, to go back, sometimes to go back also to the concept of the past, design a building based on the climate, design a building based on the fact that you want to use as less technology as possible, as less energy as possible. So we are really in a strange period. 120 years ago, with the first air conditioning building, it started a sort of disease that pushed all the users to look for an indoor environment that is always the same and push the architect to make things not as that don't fit anymore that much with the climate where those buildings are made. So I think that really this project helps to look also to that and force you to look at the fact that if you want to make really something that uses little energy, you need to work on the design carefully. You need to consider who's going to be inside of the building, and you need to consider where the building will be.
To me, I think affordability is still quite key, right? And we've been having some discussions internally these days, and yeah, when we talk about these plus energy buildings, technology plays a huge role, and it comes with risks. And you know, when you are pioneer, you are investing and having like a high cost. So I think making it affordable would be a way to move forward faster. But at the same time, we as designers, I think we also need to think of other alternatives. Maybe our project is pushing for the technological path, but we also have to reconsider maybe can we do with less technology, and would that be more affordable? Not all of us have to live in plus energy buildings, maybe, but we might have, you know, different paths to achieve the same goal. So just to, yeah, think of different options and the affordability of all of them.
Yeah, to me, maybe very much connected to what Wilmer was saying before, but also a bit with what Beatrice just said. It would be also awareness, which I intend in, considering the different stakeholders when we deal with building and building design. So awareness from designers and the different, many kind of designers that take part of designing a building. We also heard yesterday about the design of this building, how teamwork is key. So there are many stakeholders even in the design of the building, but also stakeholders as the users afterwards. So awareness of what, in this case, positive energy buildings, but in general, how buildings works and how we can have an impact before at the beginning on designing it and later on using it. So I think awareness is something we can work on, and it's really important.
Yeah, one could obviously talk about legislation, regulation, economic incentives, and so on, but I like also to think that those buildings could be like flagships for some kind of European way of designing buildings. So at the moment where there are, let's say, politically lots of changes, there could be a European style of architecture that would be the one that we are describing now. And yeah, so those buildings could be some kind of flagship for this concept.
Okay, so I cannot add too much to all what was said up to now, but the one thing I think we should widen our view, because the plus energy building is one single building, but does not solve our problems we have. So the designers have to think also about the surroundings, the neighborhood, all the whole quarter, like we have here, for example. This is really important because not each building can be a positive energy building. So this should be taken into account when designing buildings and also designing the technologies. And make it, in this case, it's also important to make the technologies flexible for use in the neighborhood. So this most concern is electricity consumption and distribution of electricity, but also maybe the heat is same, can also be distributed in a district. So that's also an important point.
I think that all the issues that were mentioned before are all of them really valid, really fundamental and critical for plus energy buildings. I wanted, however, to add something regarding the affordability, because I think another key word, another key issue is also the service life. So ensuring that the technology can function as best as possible, as long as possible, because making something that is affordable and is not long lasting, then it causes also extra material consumption, extra consumption of resources. So we should really make sure that the use quality that are key, or the key technologies that are key elements for the plus energy buildings are really long lasting, so that the investment, the economical investment, but also the environmental one, at least we made it one, but it's worth the money and the impact.
Thank you. So I think it's time for the coffee break. We have to close the panel, but we will follow up in the next session, where there will be the demo cases, the presentation of the technology developments, and then we will conclude in the afternoon with the policy session. So thank you all. Enjoy the coffee break, and see you later. So I kindly invite our technology partners to sit here on the stage. We are having now a pitch session on technology development description. The project has 4 companies as partners dealing with different technology developments, from house management system to active window system, up to ceiling fan systems, and the packed heat pump and storage system. So we are having now a short presentation by each that shows us which was the innovation brought into the project thanks to this. So let's start first with José de las Heras from Advantixis, and his presentation about the cloud-based management system. Please, José.
Thank you. My name is José de las Heras from Advantixis. We've been mainly involved in the development of the Culturali house management system. I'll give a brief presentation of what we have done during these 5 years. Well, of course, when we talk about plus energy buildings, we are talking about energy efficiency, energy optimization, and here the technology we have developed is obviously crucial. But I would say this is not about technology itself. Technology is already in the market for some years, for a long time. It's more about how people interact with the spaces they live, they enjoy. And technology there is just an enabler. So it's not nothing else than an enabler. So how do we make PVs really smart, but efficient, but user-friendly? That third word, I think, is the critical part. Let me introduce a bit our house management system. It's cloud-based. user-centric, as you have noticed, this project is user-centric, designed to optimize energy use and enhance comfort. We developed two core interfaces, because when we are talking about users, normally we are referring to occupants, but it's not only the case in the usage of house management systems. We develop, based on the same cloud-based backend, we develop an app for residents, so they can interact with their real-time energy loads, energy control, and personalized comfort settings. But besides that, we care about building managers. Because at the end, the data we are collecting is probably much more useful for them to perform maintenance activities, to optimize the different subsystems, and to learn about historical data. What we developed was fully integrated with the different subsystems in the demo sites, including renewable energy sources, storage systems, BMS already installed, and environmental sensors. So, how we engage users to be energy efficient? Well, we had, as I said, we developed an app, but there are many apps in the market that can connect to the different gadgets you can install at home. So we had to provide additional features that could be of interest for the users, but also for the overall goal of making or having a better energy behavior, energy consumption behavior. So through this app, we, let's say, let the user interact with the different environmental controls, which is something not easy due to the different protocols, different subsystems that are running in the buildings. We promote low carbon choices. The app provides real-time energy data from the grid so that you can see in real time where your energy consumed is coming from, if it is, what is the carbon intensity at that moment. So somehow we are encouraging users to use their appliances or to shift any load when the energy mix is greener. Something, of course, you cannot force them, but it's something that with this information they can be informed about current situation in their particular region, country. Also, occupants can compare consumption patterns with other neighbors, but also against themselves through the historical data analysis. Again, we are not saying anything with this, let's say, comparison, but to look, this is what you are consuming, this is what your neighbors are consuming, it's your decision. The decision-making process includes you, but it's up to you what to do. No? And finally, data-backed decisions for building managers to fine-tune performance at scale. Again, we are not only referring to the occupants, we are referring as well to the people who will maintain the systems in the future. So we made the HMS work in real-world PEVs. So how we did this, it seems easy, but it is not. We developed a modular and scalable solution, so able to be adapted to different building types, climates, and I'm an IT guy, and the second point is what most concerns to any of the engineers working in this field, interoperability. We support interoperability with industry standard protocols, and this is normally a nightmare. This is what we call data silos. I mean, if you don't break these different silos among different technologies, you cannot control as a whole the system itself. So about the future. The HMS is not a software, it's a live solution which bridges technology and people's daily lives. If people don't use the HMS, then there is no point in our development. So we cared about it. We developed an engaging, adaptive, and impactful solution. And looking ahead, well, we think having this kind of digital service in which you can monitor your building, your comfort, your energy loads in detail, can open new markets. For example, the demand response schemes that are being discussed at EU level, at national level. So basically, this kind of platforms will make buildings and hence users participants of the energy markets. For example, shifting consumption based on grid needs or renewable availability. And here it opens new questions. We were talking about earlier about affordability of PVs. Well, if we are able to make these PVs part of the demand response scheme, for example, then users, owners can get value of the investment they made when they built this kind of PVs. So yeah, basically that's all. It was a short pitch, but I think it summarized what we did in the project. Thank you.
Thank you. So the next presentation is the packed heat pump system, and it's Dr. Bertrand Del Pech from Brunel University, who supported the industry partner, Ventive, who developed the packed heat pump system, including quite a compact storage system that you've been working on. So please, Bertrand.
Thank you, Maria. So yes, so Ventive is the company that manufactured the heat pump, designed the control software and things like this. However, throughout the 5 years of the project, we've been working very closely with them to test the different components, look at the compression cycle for the compressors, etc., trying to enhance the efficiency of their particular system. So, well, the heat pump that was developed for the project really was aiming at a few solutions. So currently, you can see on the right, fairly typical heat pump installation. So you usually have a split unit, which is located outside. And then you have a plate heat exchanger, and all the rest of the system is usually located inside. And you also need to add water cylinders and lots of different things that needs to be installed when you're on site. So integrating a heat pump in your house, well, usually roughly, so if I take an example in the UK, a company that is very famous for installation of heat pump like Octopus, will take about 3 to 5 days to install a heat pump in your house. And that is quite a long time. The idea behind the packed heat pump is to provide an all-in-one solution, which has thermal storage, control, able to provide district hot water, heating for the house, ventilation, all of this in a single component that can be installed in less than 1 day. So that was really the aim of the packed heat pump. And so this is where we started from the Culturally project at the very beginning with the conceptual idea of this system that was previously tested in Brunel. And the aim of Culturally was to take this system to a TRL7 component that can then be further tested for CE marking and all of these type of things. So this is currently the technology, and this is the Ventive heat pump. So the Ventive heat pump, you can see it at the bottom here in black. It's able to provide different type of services for the house. So the main one being the ventilation, the hot water, and the heating and cooling. Now, one of the advantages that this heat pump has over other technologies that are currently in the market is that it will use the heat that is inside the house to as a heat source for the evaporator of the heat pump system, which means that when you circulate the air within the house, you have to bring sometimes fresh air to reduce the level of CO2 inside the house and increase the comfort of the people inside. Most of the heat pump and most of the system is usually done through just exhausting the air, the warm air from the house and injecting fresh cold air inside the house, which means you have a large amount of energy that is lost to the environment, and this is quite a cost. And this is one of the issues with the current system that are installed. However, with the Ventive technology, we are managing the entirety of the air inside the house. So we will take, for example, the air that is coming from the bathroom, where you have quite high humidity content. This air will go through the heat pump. The heat will be absorbed at the evaporator of the compressor, and then this stored dirty air will be evacuated to the house. In the meantime, we'll bring fresh air. That will be, so in the top section, we have a air handler unit, where we have a heat recovery system that will allow for this cold air from outside to be warmed up slightly. So we reduce basically the energy that is exiting the building. The idea of really the energy of the packed heat pump is to maintain as much as possible the energy inside the house so it doesn't leave and you don't have to increase your electrical costs for the system. Another thing that we included in another technology that we included in the packed heat pump is the thermal storage. So the thermal storage is phase-changing material storage, so high-efficiency storage. If we take an example of the one that we have in culturally, if you were to take similar storage based on water, that will be a 250 liters cylinder. While for our technology, the PCM is about this high. It's like a 700 by 500 by 500, so very small footprint, and they allow us to store much more energy than a regular cylinder that you will have in any type of flats. What that brings us as well is that we brought the idea of doing demand shifting. So you will usually use more the hot water, especially during the day when you have showers or this type of things where you have quite a lot of demand on the heat pump. And during this time, usually, I don't know if it's the case in Belgium, but in the UK, we have off-peak and on-peak where the electricity price is much higher, basically, during the day. We're looking at 25 to 35p per kilowatt hour, while during the night, it's about 6p per kilowatt hour. So the idea of the PCM is to operate the heat pump during the night, where you can store the energy to the maximum, so you fill up the battery to the maximum. And then during the day, you stop the heat pump, you don't use it, you just use it for the ventilations or things like this, but you try to use it as less as possible. So you can basically shift your cost of electricity during the night, and you save about 40 to 50% based on your tariff, which is why we brought this particular technology in the project. Other than the hardware, we also have quite a lot of work that we've done on the sensor and the control strategy of the heat pump, trying to make it much smarter and more reactive than the current heat pump in the market. One of the issues that is in the market currently for heat pump is that if it doesn't have a storage, it will take usually quite a long time to warm up. So a heat pump is completely different from a boiler. A gas boiler will provide you hot water at 90 degrees almost instantaneously. A heat pump will take, let's say, 2 to 3, maybe 5 minutes to warm up, and that is not possible for a user because they will just waste water, and that will damage the comfort of the user in the house. While our system, using the PCM, so the phase-changing material, we have an instantaneous demand, and we can program the system to know that if there is a PCM usage, we need to start up the heat pump to make sure that the PCM is full again when the user stops using the hot water. So it's all about looking at predicting the behavior of the user to make sure that the hot water demand is perfectly matched in an instantaneous way, and also looking at the district heating, so the central heating, trying to look at the user behavior, so where are they located in the house. They can also program when they want the heating to be on or off in a different area of the house as well. So the system has different zones that can be targeted, and then the user can have an input on saying, well, I want the bedroom to be only heated between 6 and 8 p.m. when I'm inside the bedroom, or I want other places in the house to be switched off overnight, for example. So there is quite an interaction with the user to a certain extent, meaning that they can control the temperature in a different zone of the house. They can control when the hot water usage is done. But in terms of the operation of the heat pump, the ventilations and things like this is not something that the user has access to. And the only reason for that is because we are dealing with a system that has compressed gas and things like this. So we need to ensure that the user inside the house is also safe, so he cannot access any of those particular components. So this is the packed heat pump. So our idea behind the packed heat pump was to make something that is very modular. So if you look at the current technology, when you have to install a heat pump on site, you need to bring an F-gas certificate engineer, so an engineer that is able to handle refrigeration system, because the system needs to be charged with refrigerant once it's installed. While our system, so if you look at the bottom, this is where the thermal storage is, so the phase-changing material storage. Then we have the hydronic module, which contain all of the control system. It contains also the pump, the circulation pump, the backup heater, all of this type of components. Then the refrigeration module, which contain only the compressor of the heat pump, the evaporator, etc. So just the refrigeration system. And then on top, we have the air handler unit, which include the heat exchanger for the recovery of stored heat in the air before being exited from the property. Now, the idea behind making this modular approach, and I think that's something that was discussed in the previous panel as well, is about the durability of the product over time. Okay. So our aim was to install a product that will remain in place for the next 30 years, at least, but every part can be removed and replaced. So the aim of doing this module system is the refrigeration module is usually the one that needs to be changed, that needs to be maintained because it has a refrigeration. Over the years, the refrigerant will tend to leak. There's nothing we can do about it. It will leak at some point. So the performance of the heat pump will decrease over time. Now, instead of having to replace the entirety of the component, you can just remove the refrigeration module that is then sent back to Ventif, repurposed, and, well, refurbished, sorry, fixed, refurbished, repressure tested, reconditioned, and then installed in another system. So at the end, after 30 years, your heat pump, especially the refrigeration module, will not be the same. So it will be maybe a refrigeration module that was in Germany, in another place, that was sent back to Ventif, refurbished and sent again. And all of that is to reduce the amount of waste we generate during the exploitation of the heat pump. So that was one of the main reasons why we did this system. It's a little bit more complex to manufacture, but at the end, it's more beneficial to the end user because they actually don't need to change their system after 15 years. Yeah, so that's more related to the maintenance and the modular aspect of this. One more component we added as well in there is that all the sensors are inbuilt. So we don't need to install any sensor in the property. We can manage the air temperature of the property through different systems. And also if the user do want to maintain different type of temperature in different rooms, we can add sensors on their heaters, for example, to modify the temperature in the building. So where we stand in the market after culturally. So culturally really allowed us to develop our ideas, our concept, all the way to an actual commercial product that is currently CE marked. So we're hoping to get the Ventif is hoping to get the CE marking in 5 to 6 months. CE marking for refrigeration and heat pump is very complex. There's lots of things to account for, so it takes a little bit of time. But currently where we stand in the market with our solution, so here you have like different systems starting with the ground source heat pump. Ground source heat pump are amazing, the most efficient heat pump, but the installation cost is very, very high. Looking at the culturally project, for example, it's just not possible to do that because there is no, you need a garden, you need square foot where you can actually put the system. Air source heat pump, it's the problem with air source heat pump is the cost is quite high, but it's also split unit, so you need to have one inside, one outside. So it's a little bit more expensive. And in terms of air management, that's not something that is done. Exhaust heat pump, that's let's say that's mainly our competitor. It's very close to what we do, but they don't have really storage capacity and in terms of recirculation of the air in the property to maintain a low level of energy consumption, that's not something they do. But in terms of cost, we're fairly close to that. So we're quite well placed in the market, and we're hoping, after culturally using the result of this project, to be able to expand even further the market where we are in. So we talked a lot about user. So as I mentioned, for the heat pump, we do have restrictions in terms of what the user can do on our system for safety reason mainly. But we try to, so we developed an app like most of the smart system now, where the user can basically track the usage, track different type of data for the property, and they can also modify the behavior of the heat pump to some extent. So like we have, for example, an auto mode where they don't have to do anything. They just set the temperature of the house, and then they leave it be. They don't do anything. But we also have some level as well of integration. So if they want heating, if they want more hot water, etc., there is like we also have, for example, a booster mode where the heat pump will work extra. So we'll take, instead of operating, for example, at 500 watt, it will operate at 900 watt for a certain amount of time. So the user can have extra hot water. So that was, for example, one of the case you mentioned when they have people coming over or something like this, as something maybe they want to increase the temperature. So the heat pump needs to be capable of providing this type of heat. And so yes, this is where we are currently. And culturally has been very positive for us because we were able to do an installation in France, and we also have soon an installation in Germany as well, where we'll be able to validate our models and development. Thank you.
Thank you, Bertrand. Yeah, next one is the active window system. Can you pass it to Giovanni? Active window system is more than a window. So it's actually a window that can be configured to different climate and can entail different functions. So I'm glad to present you Giovanni Tognato from Eurofinestra. Please.
Thank you, Anna Maria. Thank you, everybody. And as you said, I'm Giovanni Tognato from Eurofinestra, Italy, and we produce window. And in this project, we have worked on active window system. Firstly, I would like to say that we have to change word from window to window system. I mean, I think that Windows has always been a system, and it always been complex. And I don't think that today it's more complex than in the past, but I think that today we have different tools. We have the possibility to calculate quite everything, and we have maybe the consciousness that we can't still put power and machines in our buildings to fill the lack. I mean, it's too hot, okay, pump cold. It's too cold, pump hot. I think that that time is quite passed away, and we have to go back to look to the base of architecture, and with the consciousness and the possibility to mix them with the technology that we have. So why this is a window? Why I call window system? Basically because through that we can control first the shading, and when we talk about shading, we talk about light. But talking about light, I mean it's a big argument. Through the light, we define the space, we define the quality of the light, and we also talk about heating. So they are strictly connected. And so light management, overheating, and we also want privacy. In general, we make that stuff in a non-optimized way. I mean, I have the light in my eyes, I close the curtain or close the shutters. I have too much hot, I close the shutters. Maybe it's a bit late. In the same way, the transparent part, we use that for air renewal and also to connect us to the outside, but also when you are outside to the inside. So we have to work on the designing of the glass, and we have a lot of parameters for that. Yeah, in the same way, we change air in a not smart way. It's hot. Open the window. I've slept here all the night. Open the window. It's cold. Okay, pump hot. But it's what we do in general. And another part is that that we require to the window and window system in general. It's a lot of parameters that can you see here? So we need thermal and acoustic insulation, we need air tightness, we need water tightness, and we need to reduce the thermal bridge. Here we have the perfect example of high energy building. The upper part is passive house building, so the design, the designer knows very well what does it mean. I mean, we have to work really good on the connection of the window to the wall, on the connection to the glass to the window. So we have a lot of technical parameters that we have to match and we have to control. In general, the solution become complex. We have a lot of persons that are involved to do that, and they can become diseconomic. So the active window system, basically, we set up a catalog of solution because the idea is to give a solution for all the Europe, and as we listened before, we have a different mentality and different climate and different conditions. So we set up a catalog. Now I present to you the last phase of the product and a design that can fit quite every require. Quite. Basically, active window system integrate and optimize the several systems. So trying to reduce the dimension, reduce the used material, integrate function, and optimize them. On the left, you see the last prototype we have installed in that blue wall is the wall. And in black is the sample. On the right, you see the base configuration of the product. So we have a opaque part that contain a smart ventilation system. We have a smart shading in the transparent part, and we have an adaptive frame. I'll try to explain the different part. Firstly, starting from the adaptive frame, we made a frame based on two material, basically, wood and cork conglomerate. It's a patent that we made in 2005, and we maintain and increase year by year and improve year by year and put in our product. Basically, the frame has one dimension, but increasing the quantity of cork conglomerate, we set the thermal transmittance of the frame, and we set up one frame for the Mediterranean climate and one frame for the cold climate. As I said, the idea is that the material that we use are natural, renewable, recyclable in all the product. About the shading system, it's quite like a double skin technology. I mean, we have an IGU, we have the shading system, ventilated cavity where we can manage the flux of the air, so we can use it like a pillow, cuscino, like a pillow of air. Yeah, buffer. And this is the shading system. This is totally openable because it's another key point. All the technology and all the parts inside the system has to be replaceable in easy way. In the opaque part, we have a ventilation machine. It's small, but it has a good capacity and good thermal efficiency. The ventilation machine provide the filters of the air and the recovery energy. Operability, it's another key point. I mean, the idea is that the glass parts are bigger, quite as you want, but we will see the dimension, and you will open only if you need to make any type of maintenance. It's a semi-fixed one, and the opaque part you can open in every time also, because you have the possibility to have a direct connection to the outside. About the management, all the components are in the opaque part, and the different machines are guided by a sensor of light, temperature, and air quality. If I can go back. Okay, this is the This is the last sample. It's pre-installed here, and it's ready to be tested in that structure in EURAC. And as you see on the right, this is the possible dimension that we can scale the product from 90 per 110 to 150 per 260.
Thank you, Giovanni. So latest technology is about moving air inside the building in order to exploit the thermal comfort potential that air velocity within the environment has. So basically using ceiling fans can feel comfortable at higher temperature, and this implies also savings in terms of energy, because we don't need an active cooling system. So please, Fabrizio Miorin from Vortice.
Thank you, Lotta. Give me this. Okay. So, just an introduction. I'm Fabrizio Miorin from Vortice SPA. That is a group that deals mainly ventilation, but not only. Also heat recovery unit and other energy perspective, like similar to what we have seen before, but that the other contributors. Talking around a smart air movement for thermal comfort, we can consider this. We are sure that air movement is an energy efficient means to provide a thermal comfort in alternative with more demand energy system, the traditional cooling system, and try to take a technology from the past and try to give a new life, a perspective in the usage. Base of air movement is what we have called smart air movement, is a ceiling fan system, in which cases we have a adoption of more ceiling fan that are connected point to point by the Wi-Fi net to the local control, and the local control has 3 different layers of interaction with the end user. The first is the manual actions that the end user can provide. The second, at dualing level, can be resulted directly by a support of its interpretation with an automatic level of control. And the third is leave the floor to the adaptability BMS, building management system, in which someone far from the dueling control and decide what is the moment to use that technology in comparison to other. The most important we are deals of the system that have the cooling alternative as a focus. Based on that idea was built an algorithm that deals some variables inside the dueling, in particular temperature and humidity, but also the level of activities inside the room. So what we are able to do, and also in automatic manner, is analyze not the presence of the people inside, but how the people play the role in relax, making some action, gyms or something else, and or be studies or other activities, ironing and so, and give an indication of this, we can have a reaction from our system. And in particularly, you look at that, starting from the situations, we can modify the rotational speed of our fan, ceiling fan, just to have a more impactful action on the people, on the body of the people that extract the heat produced. At the base of this concept was important give an evaluation, and for that we have seen by behaviors and analysis a survey that we'll look at later directly on the people, on the humans, if what we have considered is really a promotions. And we have seen that approximately from 26 degrees of the internal temperature condition up to 32 degrees, we can avoid the use of more energy demanded system for cooling. On the other hand, we have generally we start from the concept that if we consider the cooling system that characterized our dueling up to date, we can see that through a space of about 50 square meter of internal area, we can use and absorb by the cooling system about 700 watts for that on the time, and the same in base of time. Instead, with the fan, we absorb about 70 watts. That is almost 1/10. So, if was it, we have tried to analyze the impact with the different climate and considering a dynamic building energy simulation that was performed by our colleagues of EURAC, we have found that we really have the perspective to save energy and electric energy that could be more impactful in the Mediterranean climate, but could be significant also in the oceanic and subarctic climate, up to leave and rise and delete completely the support of this kind of alternative system, the cooling system, and using only that is enough to sustain the peak of temperature that we can have at that. So you can see that the main important values in the high-rise residential building, we can save 58% of energy. In the low-rise residential, up to the 30. That is really important in terms of cost of the total cost of the owner. What we have considered in Iraq, we performed a survey involving about 30 researchers that consider the impact of the system directly on your body, and are able to describe the thermal comfort obtained by the system, and the satisfaction was about greater 85%. But also they have obtained a perception of total indoor air quality that was a contribution above 82%. The soundscape wasn't so impactful, and sometimes the less impactful was the movement, the perception of the movement of the air inside. Sometimes the air disturbed, but for that, the characteristic of the system use the direct flow, but also the reverse flow. And because more of our sensation depends from the relative position by the source and the position of the people, if we are far from the main flow, we can obtain by the reverse recirculation a good sensation. In any case, because we use the ceiling as a baffle for the distributions. In fact, instead, if we want to have the maximum impact on your body, we can go with the direct flow more closer to that. So, why install a ceiling fan system? As a first, because there are less operational costs for cooling than active cooling system. Can provide comfort up to 31 or 32 degrees. Can improve the user adaptations, and can also saving space for cooling system, or eventually remove from the perspective of the applications, and need less maintenance compared to the other alternative system. Because make simple is a good reason to provide technology. And this is a simple system. During the time of the project, we also introduced a different looking for our unit and move from the original to the new one that has also reduced the heights between the ceiling and the blades and the wings. Because we look in many regions of Europe that the ceiling is positioned from the floor at a lower distance. In the past it was 270 centimeters, now is 240, We needed to have a less surface around, lower volume, because it's more easy to heat, but also we have to take care that there are some safety conditions. But looking back, better the solution, we arrived to the situation there. With the integration with ABMS, we have the possibility to decide better when use this technology compared to the other. At the same time, we can operate manually to identify the characteristics of activity inside, but better is analyze the situation and make automatically a reaction on the system. And for that, we have developed a system that work with a microwave to individuate relative and the movement that there is. That is.
Thank you, Fabrizio. So this is the end of the technology presentation. I will let you go in with the audience and call the demo owners to present the demo cases. And we will have later on, in case of questions, during the lunch break, poster stages around the posters where we are will be showing the demo case and the technologies installed. So there will be time to interact with the partners. So, John, please introduce yourself.
Thank you. Hello, thanks, Anna Maria. My name is John Thompson. I work at SINTEF, that's a Norwegian Research Institute. I'll be presenting the Norwegian demo, here presented in great winter weather. I'll be presenting it on behalf of Bærum Municipality. The building is located just outside of Oslo, which is the capital in Norway. The building has 12 apartments. It is an assisted living and welfare facility. That means there are people there living which need help with pretty much everything. They have staff working there all 24 hours a day. It is a future-built project. It's been classified as it's gotten BREEAM Excellent. It's a solid wood construction, and it was built, of course, on a zero-emission construction site. In Norway, when we build, we have regulations. That's called TEC 17. It's a pretty strict regulation, which I'll come back to. But of course, we want to go better. We want to do better than that. So there are voluntary requirements or guidelines which you can use, which more and more people use, and of course, the municipalities use this. You have the low energy and passive house standards. You have BREEAM NOR. You have the future built, near zero emission building definition, and powerhouse. So, first of all, the picture there is the large one. You can see it's a picture taken with a drone from top. So you can see the roof, you can see the solar panels, and you can see what's called the blue-green roof, which I'll talk about. And there's a free space there. But reaching the cultural E-goals. Norway is forward-thinking. There's a lot of focus on BREEAM and exemplary projects like Future Built. The Norwegian regulations are very strict and are getting stricter and stricter. which is a good thing. It ensures that the buildings are energy efficient and, of course, environmentally friendly. They are designed and equipped with technology that minimizes energy consumption. And of course, this means you have to have a high insulation, you have to have very energy efficient windows and doors, and advanced ventilation and heating systems. The building are compact, it's properly oriented, and it has solar shading. Our building, we focus on minimizing energy use and using renewable energy. Of course, I mentioned the zero-emission construction site. We have a very highly insulated envelope. The solar panels, which you see there, is about 45% of the ceiling. It's 23 kilowatt in energy. The battery is now 65 kilowatt hours. We just upgraded it 2 weeks ago, so we're gonna see if that's gonna help us. Of course, we also get energy from energy wells. It is boreholes in the ground, which goes 150 meters down. And we have heat pumps to reduce the energy consumption. And believe it or not, we need cooling in Norway. In the summer, it can get quite hot, and especially in very high insulated buildings. So we have some cooling, and that's blinds on the outside of the windows, which can be drawn down. Of course, the building is built on low carbon emission materials. Just a small talk about blue-green roofs. Part of the roof is with plants, and this is very important in Norway. Many buildings use these types of roof. You have the vegetation, and it's very important to manage the water. We get some rain in Norway sometimes, and it usually comes a lot at once, and we have to retain the water, and this is a very good way to retain it. So it's a temporary storage of water. It, of course, promotes biodiversity. It gives some thermal insulation and improves the air quality, and you get credits under various BREEAM categories. So it's we have kind of a fight over the roof. If you're going to have solar panels, if you have a blue-green roof, and also some roofs have a recreational area. But here we just have a free area open. The Norwegian demo is a little bit different. It was included in the project pretty late. It was almost completely built. So we have a little different approach, or different. We do not have the technologies which was presented here earlier. We have a little. So we are looking to other things, and the key words here are simulation, sensors, hydronic floor heating, domestic hot water storage, ventilation, PV, battery, and EV charging, which is we can combine to the flexibility potential. This is also described in the deliverable 311, which we go very deep into the flexibility potential. And flexibility is what I'm going to talk about a little bit now. This building has to be controlled, so we have an online, off-the-shelf, I call it. You can buy it. It's a pretty almost complete system. BMS, the building management system, or house management systems. We call it BMS because it's a building. It's like not just for one house, it's for a complete building. The tenants or workers in the building cannot directly control the BMS. It's too complicated. So this is done by professionals. We have in this system, you can have automatic and/or manual control options if you want. You can have a rule-based control, like you can just set a threshold and the building can go to that, or you can do some model-based control, which is kind of more dynamic control system. So, from simulation to flexibility, how can we look at flexibility? You can, of course, just test different scenarios in the building, but it is, of course, much easier or better to use a simulation. This is our digital twin of the building. We model it with a program called IDA ICE, and it gives a very accurate energy performance results. It uses current weather data, and you can see the building is, there's the model, and it's identical to the real thing. It's very nice to have this simulation because we've used it to find missing sensors. Of course, we need sensors in the building to be able to control it, and this model tells us where we should have sensors, so we can put in a new sensor if there's information we need. The BMS needs to have all data from technical equipment. So it needs to, in order to the BMS to function like a complete system, it needs every information it can get. And the flexibility potential and schemes can be tested in this model on a computer. Just, I'm not going to go very into detail into this, but this is just an example of how this digital twin is extremely accurate. You can see there's just a little model with a PVs, and you can see we can choose the degree of how it is placed on the roof and how big it is and so on. And the heating systems there is extremely detailed. So we can, like it's just like the real thing actually. It's quite nice. So the flexibility is the Norwegian focus. We have the very highly advanced building, which is Tech 17, BREEAM Future Built. It's got PV and batteries, all the things you need. You have a very advanced BMS. And of course, the simulations are extremely important for us. Correct and enough data input from sensors are required. We have actually about 300 sensors in the building, which provide data like every 5 minutes, I think. So we get a lot of data all the time, millions and millions. And we can now start working, of course, with a model predictive control and thermal and energy flexibility. The thermal flexibility, we can shift energy in the heating system and building structure. We can shift energy use from high price hours to low price hours. We can have some energy flexibility, like peak shaving. You hear me? Yeah. I'll show you a little example of peak shaving later. The peak shaving reduces demand charges by shaving the peaks of the power consumptions. Of course, we have a big battery now, a pretty large battery. At first, we had a smaller one, which was just used for proof of concept. Now we can actually use it for real. So, yeah, thanks. Okay. And the energy flexibility, we can maximize solar energy use and reduce the grid dependency. I'll now show you some data, which is quite interesting and fun. This is data from the battery. This is old data, so it's the new battery will give us a much larger peak shaving. So what you see here is the battery charge. The battery is at full charge, and it drops. It drops in the mornings, because then the building uses a lot more energy. Everybody gets up, and you use hot water, and you cook, and so on. So at that time, usually the energy import should increase from the grid, but instead, the battery kicks in and shaves the top. So that's why we see a discharge in the battery. So the battery provides the building with energy at that time. This is also usually the time when the energy is most costly. So this is good. So this works. Excellent. In the model, we also did some solar energy production simulations. So the yellow is the predicted energy production in our model, and this is data from 23, and it fits pretty good, I think. In 23, we had a lot of snow, extremely. So from October to December, the panels were covered like with a meter or something. So no chance getting any energy from that those months. But in the winter time, when the panels are all clear, they produce a lot of energy. They are very efficient during the cold. In the building, or outside of the building, we have about 5 EV charge stations. Unfortunately, they are just plug and play, so you just plug your car in and you get energy. So at this time, the only way to control it is by using your car's internal control option systems. But anyway, we get the data from the energy charging. They are used every day. The reason for the large up and downs is that different cars have different charge capacities, so they draw different amounts of energy. And what we see is we have some short time charging, like 2-hour chargings, and we have longer time charging, which is probably the employees charging their cars. You know, in Norway we have a lot of electric cars, so that's why they are being used all the time. This is just an example of the imported energy, because the building is not plus energy. We don't produce enough, so we have to import energy. And this is from 2022. This is the gray one. And we have 23, and the blue one is 24. And we can see that we are going further and further down, so that's a good thing. We talked about the users a little bit, and I'm going to also do that, because in order to control the energy systems in this building, we need to know something about how the users use their apartment. So in some of the apartments, we have installed some windows and door sensors, and the results were quite interesting. In some of the apartments, the doors and windows are used like pretty normal, but in some apartments, it's not. Like this one, this apartment here, the terrace door opens about 120 times during a period of 7 days, and that's a lot. And this interferes with, of course, energy. Yeah, I'll have to speed up. This is CO2 in the common rooms. We have several other indoor air quality parameters. We also look at temperature, of course. We are not so very interested in particles, because that's not a problem, since we have the ventilation system that filters out these particles, so that we don't look at that. I'll just, I had the timeout here, so the point is here, we are trying to reach the plus energy building goal. In our simulations, we are about minus 25 kilowatt hours, 1,000 kilowatt hours away. So we are 25,000 kilowatt hours short of level 1 compliant. It is energy efficient, but it was in the beginning not scaled with the PEB in mind. And of course, less 50% of the available surface on the roof is utilized with PV. If we were to fill all the roof with PV, it would give us enough energy. This is the last slide. Yeah. So lessons learned. This used to be 3 slides with lots of text, but I'm going to take you fast through it anyway. This is important. It's very advanced, but it's a very demanding building. It was never meant to be a PEB, but a plus energy building. However, the simulations show we are getting close to a plus energy building. We have learned a lot of lessons from the digital model. We have had some problems and issues with PV, battery, and EV because they use proprietary data systems, which it's difficult to connect to the BMS, and it's not controllable through the BMS. The simulations was used for debugging and finding errors. Important lesson is when doing this type of advanced buildings, you need a coordinator, a technical integrated coordinator. That's very important. We had lots of issues with privacy data. That means privacy issues, like we can't get every data from the people living there because it's privacy. And we have some unexpected user behavior, of course, like the doors and windows. The building uses more energy than calculated, so we are working on finding what's not working as planned. However, the simulations work and they give us accurate data in return. Thermal and energy flexibility is possible. And we are prepared for more testing and doing that as we speak. Thanks.
Thank you, John. Yeah, we'll leave the question later during the lunch break because they will be around the poster to show that. So thank you for the presentation on the Norwegian demo, which was kind of our living lab for flexibility potential testings. And now I would like to invite on the floor Mr. Marco Pignatti from Habitcoop, which is the demo owner of the Italian demo case, located in Castenaso, Bologna. So please, Marco.
Okay, thank you. Thank you so much. Good morning. I am Marco Pignatti. I am a financial manager of Habitcoop, the biggest inhabitants cooperative of the province of Modena. So, the next, okay. Yes. I read the slide. Habitcoop, which has been in Bologna and Modena markets for 50 years and expensive experience in the construction of low energy building and nearly 25 years collaboration with the Casa Clima agency in Bolzano. We have caught the opportunity to participate in the European project Cultura E+, and because this project is perfectly aligned with the evolution they constantly seek to implement, addressing the 3 dimensions of sustainability, social, environmental, and economics. So the discussion, the building was 20 minutes from the center of Bologna. The Girasoli residence complex has come to live, and with highly efficient energy technology. The Cultura E project include 2 residence buildings, the building A and B, and the building C is a reference building equipped with our standard. The demo case over the Habitat Cooperative hosts 15 housing units distributed over 5 floors. On the ground level, private parking space and a garden are available, and along with the garage, with charging station for electric vehicles. The first floor, each apartment has an average surface to 1,100 meters. The first floor and the second floor is identical, and in the first floor there are very penthouse, and this building are equipped with technology as ensure comfort, energy saving, and reduce environment impact. So. This is the building C. Is the control building is a real reference case with standard technologies. Is a highly performant building. Is a full electric, equipped with a single heat pump, Casa Clima class A, and Casa A4 for Emilia Romagna certificate. There are photovoltaic system 2 or 3 kilowatts, a sensor of monitoring in 3 apartments, and there are Porton envelope for 35 with 40 EP insulation. This is the PEB demo case solution. It is the project. It is equipped with advanced planned solution, including activity windows and intelligence shielding system, latest generation heat pump, comfort optimization system, monitoring and management system. So is a very IT performer apartment. There are also photovoltaic panel and storage battery. Each apartment will be equipped with 5.5 kilowatt photovoltaic panel and 10 kilowatt voltaic storage batteries. There's the windows with smart shielding control system to optimize natural light and thermal comfort. The comfort optimized system reverse ventilation fan, which present for living and improve living comfort, and use geothermal energy to pre-temper the air, improving the efficiency of the heating and cool system. Oops. Okay. Thanks for the synergy of this technology. The PEB standards aim to produce an energy need to heating, cooling, and domestic hot water. We use the technology solution of the compact near unit combined with the heat pump, which ensure the high energy efficiency and optimal living comfort. In addition to the innovation solution, previously mentioned several key partners, Eurofinestre provide windows, Vortice offers integrated reverse ventilation system and advantages with the house management system. Also, the building are also equipped with thermal insulation of the wall, underfloor heating system in the flat of ground level, cloud-based home management system. The technology is discreet and non-invasive, as can be seen from the imaging of the interiors of the apartment, and also contribute to creating a more sustainable and comfortable living environment. We face numerous challenges. The first was legal and political barriers. Super bonus 110% is an Italian incentive. Also promotes the purpose of promoting energy efficiency is a creative market distortion, increasing construction cost and causing shortage of specialized labor. Also, complex bureaucratic process, the need to comply with national and regional regulation caused project delay. We also found market barriers, buyer reluctance. Many buyers show resistance to new technology, preferring traditional solutions such as bathroom radiators and blind that offer complete blackout. And the high cost of innovation can be prohibitive for many potential buyers. This experience allowed us to draw important lessons. Collaboration with local authorities and technology providers was essential to ensure that all adopt solution complied with current regulation and meet community need. Also, integration of advanced technology consent the integration demonstrated how it is possible to significantly improve energy efficiency and living comfort to arrive at a replicable model for a future sustainable building initiative. Updating regulation, it is necessary to update regulation, yes, and it is more important to developing a training program for qualified professional will ensure the availability of specialized labor for the construction and the operator of PEB building. Finally, promotion of incentive policy, continuing to promote incentive policies such as National Fund for Low-Income Families and the tax deduction for integrated photovoltaic system in flat blocks, supported the installation of photovoltaic system and energy sharing. Long-term support, providing stable for long-term support for innovation in the construction sector was crucial to overcoming market barriers and promotion the development of plus energy building. Then in December we deliver the first 3 houses, and families are living in our homes. At the present, we have not received much feedback. For example, that the bathroom is colder compared to the other room, and to solve this problem, we will install the electric radiation heater. The project was finished, but it may be necessary to monitor it for a few years for the good results. And I think that managing the house required a change of mindset. In Italy, we have a traditional view of the home, and many it would change the mindset of conception. So, thank you so much for the present.
Thank you, Marco. That was an interesting presentation. We tried to include in the Italian demo case all our knowledge and technologies developed in the project. Still, we found many barriers, but a lot of lessons learned came in. Next demo case is in Germany, and Hermann Leis representing Wohnbau from Steinbeiß, but also representing Wohnbau Studio here for presenting their demo case. And please, Hermann, kindly ask you to stay on the 10 minutes so we can have lunch soon.
Okay, thank you. So hello everybody again. I will start. So this is simple here. I never used it. Next slide. So I try to explain the German demo case. So I have the honor to also to speak of the part of Wohnbau Studio and the architect, which is Ringo. And it's a pity that he's not here, because he's a good speaker and he can tell you something about architecture. And I will try to do this. And I continue directly. So the site is here. You know Germany. We are in the south of Germany, near Switzerland, and near the Stuttgart, which is the capital of Baden-Württemberg. And here on the right slide, you see, I will go there. Here Stuttgart is the capital city, and it's like 10 kilometers from Stuttgart itself, and the location is here in between the residential part of the city and the industrial part of the city. And then for this reason, we cannot build a building which is only residential building. So there should be a part of commercial usage in this building. So this was mandatory here. And now this is the evolution from the architectural point of view. So we have a footprint of the site, and then is the evolution how architects develop the volume. And first the volume is quite compact, and then the next steps is to develop the floors useful for the residential use. And the lower part, this is the commercial use. So there's I don't know exactly the ratio, but about 15 to 20% commercial use in this building. This was mandatory. And one thing I would show you, you see that the roof is very big. So it was optimized concerning the usage of the photovoltaic panels. And key numbers, 4 floors, 19 apartments, 2 commercial units, and underground car parking. I continue with the typical floor plan. So we have on the right side, we have the penthouse floor. We have 5 dwellings, and first and second floor we have 8. And as you see, we have bigger one and smaller one. So we have a surface of about 60, I'm not sure, even 60 or less, and we have the bigger ones about to 90 or 95 square meters. So it's a mix of usage here. And then I come to the construction. So we spoke a lot about carbon footprint. Here the architecture is wooden structure. So we have a hybrid construction of concrete and wood. So the underground is concrete, and we have the staircase in the middle, which is also concrete here. But all the rest is a wooden structure. The slabs are of wooden structure, and also the walls also. So they are prefabricated. So now I won't go in that detail like the others did. So because it was the wish to make a pitch presentation. So I would like to show you our strategy how to come to this plus energy building. So first of all, we reduce the energy demand. Second one, we maximize the photovoltaic for energy production, because otherwise we never come to a plus. And the third also important point is to use an efficient supply concept. So I come to the energy demand. So we have 3 points. We have the building, we have the installations, and we have the user, which are influencing the energy demand. So the building, we have a high insulation level. In Germany, it's an efficiency house 40 standard. And we, as I mentioned, we have a compact geometry. And then to come down with the energy demand, we install the ceiling fans from Vortice in the commercial area. And of course, reduction of energy demand. The user is crucial, we learned this morning. And therefore we need a kind of feedback to the user to stay in the goal. Here, first step, or next step is maximization of photovoltaic panels. At the right side, you see the installed panels. Left side is a photo from last week, so it's not yet installed. So they will install it the next week or 2 weeks, I don't know exactly. Then, third point I mentioned is the efficient supply concept. So this concerns mostly the installation systems. So to get down with the energy demand, we need low temperature heating systems for increasing the efficiency of the heat pumps. So we have low temperature floor heating system, and we have also low temperature systems for domestic hot water. And in our case, we install the household appliances in all apartments. And we use highest efficient appliances like a washing machine, dryer, dishwasher, and so on, so that the apartments are pre-installed with this equipment. And then we have LED lighting. This is clear, I think this is normal. And we have the HMS system, which is for monitoring and for feedback to the user. So user can help us, but he needs a certain feedback from the system, so he should know about what he is consuming. So these are the installation systems, and as mentioned, the second point is the user. So he has two things. He has one is a feedback he gets from the HMS system, which is created by Advantixis, and Jose explained how it works. But we also added some point we know from hotels. We have an all-off button. So if you leave the apartment, you can turn off all the electricity besides refrigeration and so on. But all others can be switched off. So this saves a lot of energy. We have the experience in another project. And if we look at in graphics, it looks like this. Here we have I didn't mention we have a central outdoor air heat pump, and we have two temperature levels, the low level for the heating of the floor heating system, and ceiling heating in the offices. and we have 5 degrees for the domestic hot water system. And ventilation, we have in the dwellings, we have mostly exhaust ventilation, so in this case, we do not have a heat recovery. And I'm not sure if this is very important. So this is this is the balance, what energies we consider. So it's all besides the user's energy. The plug loads are not considered in the balance, but we use final energy. We have the boundary of the building, not the site, because it's the same in our case. We have a yearly time balance, and we have the type of balance is consumption versus production. And the calculation was the regulatory calculation. And this is the result. So on the left side, you see the whole building demand, and on the right side, the PV production in terms of final energy. And you see here, we can reach a plus energy building in the first level. As soon as we add the user, the plug loads, we increase here, and you see we do not increase the photovoltaics, so we would need more photovoltaics in this case. Okay, now a few words to cultural technologies. We inserted the active window system from Eurofinestra, and we will install the PHP heat pumps from Ventive in 2 apartments on the roof, on the penthouse. Everything is prepared, so we're waiting for the units. So I hope they will come in the next 2 weeks. And then we have the ceiling fans installed from Vortice here in the commercial part. And we could not put them in the residential part. This is due to the limited height we have and the height which is needed for the Vortice fan. So this is something which at the moment does not work together. So and finally here I show you the structure of the HMS system, which is not that easy. So now maybe you understand how complex it is to construct this, and we have 3 big parts: the room automation system and the metering system. So these are at least 2, and then we have the building management system, which is the second one, and we have the connection to the cloud system. And here we have different companies who are doing this job. So 1, 2 companies are doing this, and at the moment we are waiting until the hardware is installed. So I think also at the moment they will install it, and I hope that everything will well work with communication with Advantage, and then we can start to run the experiments. So that's about all. So it should look like this in September. Now it's not yet like this, but I think we will arrive almost there. Okay, thank you very much for your attendance.
Thank you, Herman. So, latest presentation from Julien. Hugo, are you going to present? Okay. Hugo Viot from Nobatec, who worked together with Velogia, so our one of the 4 demo owners, which is a private social housing. So please, Hugo.
Yeah, thank you. 10 minutes, okay. Because in fact there is not only 1 demo case, but 3. So yeah, I'm Hugo from Nobatec, that is a private research center dedicated to energy transition for the building sector, and Velogia, a private social housing company. So as a summary, you can see the timeline for the French demo. So first we start with this building. But in 2023, we decided to change. Why? Due to external reasons, some people living around this project was not really happy to have social housing next to. So but we did a lot of works, the design, so some lessons can be shared with you. And after we used 2 other demo cases that are now ready to collect data and have feedback. So they are in the same region, close to the city of Lille. So the first one, the Lers demo site, so Lers is the name of the city. It's a residential building. You have some views of the facade. 4 floors, balconies, 19 apartments. Here it's 3D views of the project. And in terms of technologies, it was planned to install 3 of the 4 technologies. So the heat pump with the 1 heat pump per apartment. So 19 apartments and equals 19 heat pumps. The rear fenestra windows and also the HMS, but no ceiling fan because the ceiling height was not sufficient to install the ceiling fan. So the classical or the standard ceiling fan, ceiling height was not okay to install the ceiling fan. There is in fact 2 twin buildings. So the one on the left side, it was supposed to be the culturally buildings or the positive buildings, and the one on the right side is exactly the same. So same number of floors, same shape, same occupants, same orientation. So it would be very practical to do the comparison between the 2 buildings. And these are the results of the simulation works. So you can see here that we were supposed to have a positive building thanks to PV panels. But for this project, the surface area of the roof was not sufficient to cover or to produce as more energy that we needed to have a positive balance. So we decided to put panels on the other buildings, but to consider the production of the 2 buildings for the calculation of the positive balance, because Velogia is also the building owner of it's the building owner of the 2 buildings. Yes, so in this figure, the plan is to have a positive balance based on the 5 views, so heating, cooling, lighting, etc. Due to balance with primary energy, we produce energy not only on the building itself, but just on site, so the building plus the neighboring building on a yearly basis. And yes, finally the measure was not possible because the project was not abandoned but delayed, and it became incompatible with the timeline of the culturally project. So this building will be built one day, but I don't know when. And this project also serves as a support to do some calculation, to simulation works of, for instance, here, the goal of this work was to highlight the user influence on the energy consumption of the building. So in that simulation, we define some different user profiles, so family, students, old people, and different habits in terms of control of the thermal set point, control of the shading, control of the windows opening. So thanks to simulation, we randomly assign scenarios on the 19 apartments, and the result is not only a unique value, but a range of value. So we can say that probably the energy consumption in real life, it's probably between this value and this value. So yeah, the project was stopped, but some conclusion can be shared. So it's possible to make a positive energy building in this region, in the north of France. So the climate is quite cold compared to the south region of France, but and the solar gain are not very important. But on the paper, for the design phase, it seems possible to have a positive buildings. Also replicability, because this shape of building is quite common. And there is also a lesson with the question of how to have a PV surface important to produce more energy than the building consume. Because here it was not possible to put PV panels on the facade because local town regulation, it was forbidden. So the other demo case is located in Roubaix. It's very close to the other one. It's a retrofitted building. You have here some views. So it was totally retrofitted. So the existing envelope was kept, and another one was added to reach this performance. So the goal for Velogia was to reduce the bill for the tenants. Or here you have some features of this building. On the roof, there is a lot of PV panels, so the roof is full of PV panels. And on the back of on the back side of the building, prefabricated technical shaft was built and plugged to put inside the heat pump, the hot water tank, also ventilation, so all the technical things. So you can see here the inside view where the technical shaft is here. And yeah, the goal was to reduce the bill, so divided by 3, the energy cost for the tenants. And what is interesting in this figure is the gray bar. It's the measured performance after 1 year. So in fact, it's a positive building because the consumption is lower than the production. In fact, the real production of the PV panels on the roof was higher than expected. So for the last year, it was a positive buildings. There is also some sensors, so that was already installed, and we will connect this with the HMS to collect data. And there is also something to learn. Also the question of replicability, because this building is quite common. There is a lot of building like this, 3, 4 floors, no balcony, long shape, so it's quite classical. And the last one, it's not a big residential building, but a small house. So the goal of this demo case is not to demonstrate the PEB target. It's plan B, to put the techno inside and to test. So in this small house, it's in Tourcoing, so also in the same area. You can have a look on the pictures. So at the beginning, it was squatted. So tons of waste was removed. And you have the final result on the photo on the left, on the right, sorry. So the system installed inside first the Ventive heat pump that ensured the hot water production, heating, cooling, free cooling, and also ventilation. So also some photos of the works, so the ventilation part, the step of filling the refrigerant, and it's the colleagues of Ventif that performing some tests to check if everything is okay. So some photo. So in fact, the heat pump is hid in the technical room, and there is also a backup system with the gas boiler in case of maintenance or whatever. The tenants can have hot water and heating, so we can manually switch between the heat pump and a classical gas boiler. Also simulation was performed. Here it's the result for the coldest week of a year to size the emitters inside each room. And the second technology installed in the building, it's the vortice ceiling fan. So one on the living area on the first floor and another one in the room on the second floor. So it's quite new in this region of France. Nobody installed this kind of technology, but due to climate change, heat waves, it probably will become a relevant technology. So it's quite new. Yeah, you have some photos here, and also monitoring to measure the consumption of the techno, how they are used, and also to measure the windows opening, the temperature, and how the occupant plays with these two systems, and to have some data to collect. So they are ready, and now we have to analyze this. And there is also a special thanks to the company that did the works, because it was sometimes not easy to fulfill all the requests due to the cultural project. So it was very important, and thanks to this company, the finishing is good. So yeah. Thank you. Time for lunch now.
Okay. Yeah, I think we can finally close the session. Thank you all for your patience. And in case you have questions, we will be around here for the lunch break. And don't be shy. So see you back at 2 p.m. because we will have a policy session. So from theory to practice, we encountered several barriers, and some of them could be somehow overcome with the help of policies. So let's see how we can do on this side later on. Thank you.
And there is basically two parts to it. We will focus more on the second, but basically we will be looking at direct costing evaluation of co-benefits. So if there is somehow a way to directly connect the co-benefits to a price label, which is in the market, or directly or indirectly. And to start a preference exercise, which is what you have to use when there is no such price label available for what you want to evaluate. So this is the outline of the presentation, and let's go directly into it because there is limited time. So on direct costing, basically what my colleagues did, I focused most on the other part, is to look whether there was a way to connect whatever happened in the construction and usage of the positive energy building to a reduction of polluting emissions, and particularly to carbon-related emissions. And so looking at the life cycle of the buildings, try to find all the way where this kind of emissions were directly or indirectly produced, and attach to that the social cost of carbon, basically. That was the methodology. And to find the value of the co-benefits, those were found in a incremental way, comparing the same things, the same kind of values measured at the level of a near zero energy building. So it was what you get extra after you move from an NZEB to a PEB. Okay. So they did that for three locations, basically. Italy, Germany, and France, using the parameters of the demo cases, or related to the demo cases. And there are different alternative hypotheses. I don't want to go very much into the detail, but what you can notice on directly looking at the graphs is that used in Germany, the situation was different from the rest of the experiment, in the sense that in Germany you find clear benefits, okay? While in France and in Italy, the thing was more nuanced. So basically there were results, encouraging results for some categories of co-benefits, and for Germany in particular. In Italy, it turns out that there is a slight improvement in terms of these direct co-benefits for some categories. In France, it was almost indistinguishable, the situation between the NZEB and PEB. Is there something wrong? Is that line there? I don't know. So basically, the two main categories from where you could get co-benefits were the input of secondary material, here, whoop, no, doesn't work, and materials for recycling. Those they were most sensitive, and the co-benefits range from 102 euros per square meters in Germany to values which were not really that distinguishable from zero, or even slightly negative in France. And there, basically, it means that it was kind of problem measurement, probably, and that in any case, even if you do a slightly worse situation, then the NZEB, the difference is so minimal that it doesn't really matter. You're always building something which improves on the environmental situation. Okay, so that basically is the summing up the direct cost evaluation. Of course, it took a lot of time to put together all the data, but the procedure was really a back of envelope kind of procedure. You multiply the cost, the social cost, by the emission that you, the difference in the emission that you get over the life cycle. That was methodologically straightforward. The state preference assessment of co-benefits is quite innovative, and this is something we are quite proud that we could accomplish, which is basically something that allows us to look at those kind of co-benefits for which it's not directly clear what can be the market equivalent. So you need to ask people which kind of value they put on it. So you don't have really units to measure energy security or indoor comfort in terms that there is an objective way to attach a value and sell it on the market directly. But it can be incorporated in the valuation people have of the house that they are going to get. So we asked them what was their evaluation, and we had to kind of trick them into giving an honest and unbiased evaluation. That was the most difficult part because it was, I mean, credible elicitation depends on how much people are taking seriously the question you're taking. So how much they matter for them. And so we had to really work quite a lot to get to the right questionnaire. And also we also work on the let's say, representativity of those results. And we are, by the project objective, we were constrained to look at the location of the demo cases and to select, we had found to look at 2 nations, two countries. So we took the 2 which were more central, more comparable. And in order to increase the comparability and homogeneity of the results, we took the adjacent areas which around the border between France and Germany. And we tried to get as much people as possible from the people living near the border. This is a very densely populated area. It's one of the most important economic engines in Europe. There is Stuttgart, there is Strasbourg, there is Mainz. There are a lot of important cities there. And we try to maximize the people that we got from along the border, but we consider also the neighboring provinces around that line. So we looked for 1,000 people per country, and we tried to have a kind of a even distribution between men and women, but we were not really concerned about other socio-demographic characteristics. What we were concerned about, that we were going to interview people that own their own places, so there are a kind of entitlement to making decisions about the property and the changing in their houses. So this happened eventually. The questionnaire was deployed in this fall, and I mean, it was quite took a lot to make it, to come to the right set of questions, and then in 1 week, basically, we had all the answers, and we could analyze the results. So that kind of question, you know, you don't get immediately to the point. You can kind of guide the people to the kind of information you get, and you also need a lot of ancillary information to frame the analysis. So we ask about their socio-demographic conditions. Importantly, we ask them about what they thought about the condition of the neighborhood that they were living in. So if their evaluation of the place and the changing in the condition of the housing could be determined by the place where they were living in, and the condition, of course, of the dwelling. Also, we were interested in knowing if there had previous experience in renovations, and if there were connected or to positive energy district, or if they are solar panel installed. So if there were already, like, with a foot into this kind of discourse or not. Then we had the value elicitation exercise proper, so I will describe in a moment. And then we close with some other standard demographic and briefing questions. Also, for instance, whether they were been working in the sectors, and they had previous experience on this. Okay, so what we, when it's not going, okay. So basically, we had to distill what could be understood in a quick way and in a clear way within a questionnaire in terms of attributes that define the presence or the absence of co-benefits, and present them within a choice kind of experiment in which they are to determine the value of different situations. So we describe in very concise manner, using this kind of scheme, the situation of a hypothetic house similar in any other respect to their own house, except for those changes, okay? So, and those changes could have been, could take different levels. So they could be exposed to different level of outages. They could have the connection or not to a positive energy district. They could have an advanced ventilation filtration system or not. They could have sensors for regulating in a smart way their indoor comfort and their use of the appliances connected to their houses. And this is quite technical, but basically there are a number combination, and we choose them and we select a system to propose them in a very efficient way, in order that you didn't end up having trivial questions, trivial situation of these like all zeros or not. So every person were presented 7 times meaningful combinations of these attributes. What was the question? The question, this is very important. The question was, what would have been the value, the rental value of their house if they were put in the market with those characteristics? So first we asked them, what is the rental value of your house now? What do you think it is? And then we asked them to imagine what would be the change when those characteristics changed. This is something that, so this is exactly what I was saying, 7 times redoing this thing. And then we had ancillary elicitation experiment in which we asked them for the willingness to pay to be connected to a positive energy district, and if there were, if they didn't have the photovoltaic panel installed, if there were, if they had the willingness, they had the photovoltaics installed, they asked them to how much they were willing to accept to provide their energy within a positive energy district. If they didn't, how much they would be willing to pay to get to be connected to such energy district and get their electricity from the microgrid. This was designed to have a better view about the energy security kind of co-benefits. And this, since the connection to photovoltaics energy grids comes with a kind of market situation, it could be a seller or a buyer, we have to expand this part, otherwise it would have been we would have been capturing only part of the co-benefits. And this was the question that they were seeing in the questionnaire 7 times, and they had to say whether the value of the house as they proposed were to change or not, and if it would increase or decrease, by how much. Okay. So what was the results? Well, first we have some clues about what are the characteristics of the people. So we had a lot of descriptive statistics that tell us that most of the people live in a single family home, and that most of the people have a university degree, they have a job, and their house is quite new in the sense of the time they moved in, but not only 1/3 or less have been built recently. So most of the houses actually are from before the year 2000s. Then we have information about the energy use, what kind of fuel they use. Notably, there is a lot of use of gas and electricity. One thing that was quite surprising is that 1/4 of the people have already photovoltaics installed. So it's quite a good news, and that allowed us to have quite some significant responses about willingness to pay, willingness to accept questions. Yeah, there have been some exposure to blackouts, but not so much. Mostly just 1 or 2 blackouts. Okay, the things are quite different between France and Germany on some aspects, like there are a bit more single-family home in France. There is a bit more use of gas in France. There is definitely much more photovoltaics in Germany. And the participation in a positive energy district is much more in Germany. The size of the house is also slightly different. French houses tend to be a little smaller than German houses. Yeah. Okay. So the fact that I mean, did this question work? Were people able to provide a good, realistic value for the house? Yes, most people were able to provide a realistic value. And we see that this value also changed in a reasonable way according to where the house is located. If the neighborhood is a promising neighborhood, or is a neighborhood which is having some problems of being a nice place to live or not, and the characteristics of the house and socio-demographic characteristics of the owner. If the house had photovoltaics, generally the rental prices that they were assuming that would have been reasonable would have been significantly higher. And people that were used to rent houses, so they have been renting their house or other houses, they were more eager to get money. I mean, they had probably a better sense of the value of the house on the market. Okay. So they were able to give a reasonable value of the monthly rent, about 1,000 euro on average. But one thing that we noticed is that there were quite a lot of zero changes answer for our attributes. And this is not a big problem per se, because it's normal that you may think that a small change in some attributes may not induce a change in the value of the house. Is perfectly legitimate. We expected that to have some zeros, not many, but I mean a good deal. We had a bit more than we expected, so we cleaned up the data of the people who were always saying there is no change, because those could have been protest answers. So let's say half the people of the answers now were with at least some change in the value of the response. So there is the Gaussian here is very concentrated around 0 in terms of change in the value, but this is quite normal. So it would have been bad if those zeros were almost the totality, but there were not. So we had quite a representative sample anyway, and it was good that we had a big sample anyway to start with. So the change in monthly rent is dependent, as you say, if you look at the stars in this column, that tells you that having exposure, if your house has the presence of those things that signify the presence of co-benefits, so they have air filtration, they have air ventilation, they have apps to command your heating and appliances and so on, and you are connected to a pad, the value of your house is going to improve, and by those amounts. So there is quite a good response in that sense. So we had a good response and a good possibility of estimating our value. And if we do the math of those values, you have this kind of value in terms of euro per month, that having these co-benefits signify in terms of value. So you having a good environmental quality brought about by extra ventilation means about 54 euros more on your rent estimated value of the house in Germany, and so on. So those are nice, reasonable value for those co-benefits. And it's okay. Do I have to change? No, okay, it's working. On energy security, we were able to do some more work and some more studies. So we were able to estimate the willingness to pay as a customer. So 34% of the sample were willing to participate in a positive energy district as a consumer, and their willingness to pay was about 468 euros a year. So the people would have been willing to pay that much. Now, sorry, this is the value they put on the rental value. If you do it, if you ask the willingness to pay, you see that, of course, is the lowest bid gets a higher percentage, but this, on average, means that people are willing to contribute money to participate in a PED, and I will give you the figure in a minute. And also, on the other end, people are willing to get compensation. Of course, the higher the money, the more people are willing to get compensation to provide their electricity produced by their PVs into a positive energy district. So that means that with willingness, in terms of willingness to pay, our computation would give about 420 euros a year of value of participation in a positive energy district. And you can work out from these figures, particularly from what you get by asking to the homeowner directly the willingness to pay, a value of lost load in terms. So you can basically transform the figures from euros per year per square meters or whatever in euros per kilowatt hour. So since we can compute how much they consume, how much they auto-consume, so what we can compute their net consumption and what they would be left without of that consumption if outage happens. We can we can compute what would be the average duration and the average electricity loss due to an average situation of outages, and if we attach the value if we divided the value we computed per year by the kilowatt hour loss per year in a normal scenario, we would get the value per kilowatt hour lost, and that would be about 20 euros in France and 36.5 in Germany. And if you look at their willingness to pay, the willingness to participate ranges between 500 to 1,000 per year. So the willingness to pay basically is included in the values of the rental change and the willingness to accept. So basically what the people are willingness to provide in terms to participate to a positive energy district is in kind of in line of what people would like to get in order to let their electricity be provided to a positive energy district. So basically this means there is a market, possible market here, and a range of values in which people would agree that is profitable for both parties. Okay, concluding. So the direct costing exercise at the beginning pointed to moderate values for some co-benefits, which were derived as incremental values compared to NZEB buildings. The stated preferences assessment cannot distinguish between NZEB and positive energy building because that would be too much to portray to people. I mean, it's difficult to give the exact difference in a scenario. So we had to put them in a scenario in which they would have or not have the characteristics that bring those co-benefits, okay? But they were able to put a value on that. And it's a significant value, and it's a value that is seen by the people as having an impact on housing values. So it's something that people think that can impact the market value of the house. And this is important for a policy perspective because it's something that people can understand that if a house has this kind of characteristics, it's legitimate to have a change in the price they are going to pay. So it's I mean, if we market well this conclusion, you will find people responding and being willing to pay for that. We also find that energy security is important and can be and a value can be placed also in the fact that you are connected to a network. So you can go behind the fact of being in a building, but you are in a district. So as we were saying at a certain point yesterday, that it's not only the building is an important unit, it is also the way the building is connected to its neighborhood, and if its neighborhood is positive in terms of energy, the better. There is also value there. Okay. Okay. So that was what I was saying. It's important to factor this in the way you promote those kind of buildings. You communicate about this building, and it has potential to attract people to this kind of living way of living and habit and dwellings. Okay. So this concludes my presentation. Thank you.
Thank you, Andrea. And now it's time for the roundtable. So I invite on the stage, Judith Kimpian, right? Am I pronouncing it right? She's the chair of the Sustainable Architecture Group within the Architect Council of Europe, and she will moderate this session. So I leave you the mic.
Hi, everyone. Thank you for joining us for the debate today. And I know there's going to be a lot of responsibility on us to try and summarize the takeaways really concisely. And we have the good fortune of not just having the panelists that are listed on the board, but also Pau Garcia has been able to join us from DG Energy. And if I may ask all the speakers to say one line, say your name please, and the organization that you're from, and the topic you represent. And your role in the project, if any.
Good afternoon, everybody. My name is Eleftherios Bourdakis. I'm a project advisor at Cinea. My background is in energy efficiency in buildings, and I had the pleasure to be the first project officer of Culturally.
Yes, good afternoon, everyone. I'm Victoria Tsarano from BPIE. I'm an architect as background, but currently I'm a senior researcher working on positive energy neighborhoods. And mostly I work on policy aspects and financing.
Hello, I'm Andrea Picano. If you remember me from before, yeah, it's the guy who worked on co-benefits in evaluation in the project. I'm an economist, an energy economist by profession, and I work at CMCC as a energy and climate economist. Okay.
Hello, I'm Pau Garcia. I work at DG Energy B3, which is the unit in the Commission in charge of dealing with the Energy Performance of Buildings Directive. So I'm dealing with that. And background-wise, I'm a mechanical engineer, so I think today I'm probably in a bit of a minority here. Thanks.
Good afternoon, everyone. My name is William Nelissen from Wonen in Limburg. We are one of the social housing companies in Flanders. I'm responsible for everything what's on innovation within also projects like Access around PEBs and PEDs, and I'm glad to share some knowledge and experiences.
Roberto Lollini from Eurac Research. I contributed to the proposal preparation many years ago. And I also supported Anna Maria in, let's say, coordinating the project along these 5 years. My background is in engineering and building technology in particular, and I'm coordinating a research group on energy efficient buildings in Europe, dealing with building technologies as well as indoor environmental quality and use of data for developing interesting service for different players and stakeholders in the building industry. Thank you.
Thank you so much for all of you. Please note that I'm not the only architect on the panel, but that this event has been organized by architects. And so there will be a little bit more emphasis on the role of design in this topic and how that can maybe help scale up some of the amazing solutions and proposals that we have seen today. The other architect is Victoria. And but both of us now work in environmental policy and net zero, and in particular, both of us worked a lot on the energy performance of buildings directives on behalf of our organizations, and I chair the Architects Council of Europe Sustainable Architecture Work Group. So I'm really fascinated. We started off looking at the user experience and how what value these projects were bringing to the topic of net zero. Then we looked at the case studies in a lot of detail. And then we started talking about the co-benefits. And I wonder what would be really the key benefits in terms of scaling up these projects. And maybe we can start with William, because it's a case study that we haven't heard much about before. But if we are going through a housing crisis across the continent and beyond, and it would be really interesting to hear your thoughts about how some of these techniques and approaches could be used in social housing and what's needed to scale them up, if at all relevant.
Thank you. Yeah, in social housing environments, you have a lot of issues to deal with. one of the most important is the renovation, the energetic renovations of our housing stock. And we are trying a lot of new technologies to realize that. Like a project like Social Energy Sprong, where we are working on positive energy houses. But the Access project learned a lot of how to manage a PEB, a plus energy building within a neighborhood. We used one building to get some things solved in the neighborhood. It was a renovation of a building. We put there a lot of technology within it, but we learned that we can use one building in a neighborhood to get a whole neighborhood sustainable. First thing we learned is that because all the techniques are future-proof, we can deal with them by our own. It's very much interesting to get a building like that managed by one owner than by 30 owners, private owners. Second thing is we are using positive energy buildings to stabilize the energy demand in the neighborhood. That's a big issue in Flanders, in the Netherlands too. I don't know in the rest of Europe, but at this moment our energy systems from the grid are not strong enough to put in every single house, in every single building, an energy system like heat pumps or other things. So we can use within HeatNet, with energy positive buildings, we can provide energy to the other houses, also to heritage solutions. We have a project where we are putting new building stocks in a neighborhood where we have heritage, and we can solve some problems at that manner too. But the most important thing for us as a social housing company is that we can lower the price for our tenants. It are the people who need the money the most. And the Access project learned us in 2022 that we can provide energy for domestic hot water and the heating system for about 600 euros a year for those tenants. If we had a normal house on the same neighborhood, it would be about 1,800 euros. This is divided by 3. That's very important that we can solve some financial issues also for those tenants within the use of energy systems and PVs.
Thank you, William. And so that's really fascinating to hear that there are direct energy benefits, energy consumption benefits, and in particular on a neighborhood scale. And one of the things that many research projects are finding is how important to look at these aspects at a neighborhood scale. And so not just that, but looking at architectural design on a neighborhood scale and looking at the in-between spaces between projects and how all of those aspects work together to regenerate areas as part of the renovation wave, right? It's amazing, though, that you have found and you have been able to control these technologies in this way on social housing projects, which have relatively low budgets. So I wondered whether we could ask Roberto, what are the things beyond the energy consumption that this project has uncovered as direct benefits to end users in particular, but also potentially to investors? So you have talked a lot about the improved environmental quality. If you can elaborate on some of the other aspects, we would be really interested to hear.
Thank you for this question. I mean, you already mentioned the indoor environmental quality, and this is, to me, the first point. And of course, having does it work? Yes. Yeah, but it works. Yeah. So in general, I would say we must work for the home value. So it means that people living or working in a building must find, let's say, a perfect place where to stay. So this is the main and the starting point, and we can achieve this through high quality architecture and starting the design around the people needs from comfort point of view, health point of view, and also chance to use the building in different ways and exploit the fact that the building is within a larger neighborhood with some infrastructure. So these are aspects that we considered in the definition of our solutions. So more than just reducing energy needs and producing energy through renewable sources, but as I said, creating something that first of all produce people well-being and quality of life, and then of course also try to increasing the awareness of people. That means also moving from efficiency to sufficiency. So it's not only to, let's say, produce a certain result in an efficient way, but also to actually understand which are the needs for a specific cluster of people living in a specific building, and then, as I said, design the building around this specific need. So that's, to me, is a change of perspective and change of angle to consider energy efficiency, as I said, transforming in energy sufficiency. Thank you.
Thank you. And it's such an interesting statement that we designed the building around these technologies, because I wondered some of the examples that you showed, to what extent was that actually happening? For example, one of the buildings, you mentioned the presenter about the ceiling fans. I would love to have one of them because it would make my life a lot easier in the summer. But I realized that a lot of people, including the new building that you mentioned, it didn't have the ceiling height to accommodate the ceiling fans. So when we talk about sufficiency and the concept of sufficiency, are we considering the right things about sufficiency when it comes to the design of buildings? Victoria, what do you think?
EV cars as renewables, but then questioning ourselves, do we even need personal cars, or do we opt for like sustainable mobility or public transportation? So that's a bit the sufficiency angle. So if you apply that to buildings and you look at the buildings within their neighborhood, within their mobility, electricity grid, district heating, etc. You can find place-based solutions with local. So these are not around technologies. Like, it's not a package of technologies that you just copy-paste in whatever building or neighborhood, but you find the right, because we have a lot of available technologies. We've seen them in the afternoon, but finding the place-based solutions would be like, you have so much potential to reduce overall energy demand with the sufficiency principle first, and then go into energy efficiency, and only the final step is to put those PVs.
Yes, indeed, because there is indeed, so what we have seen in a lot of these projects is there is a huge amount of pressure to make these spaces compact, because when we do the energy modeling, the more external area we have, the more heat we lose and the more energy we need to heat them, right? So we just share this microphone. So in terms of the sufficiency, there are other considerations. So for example, if we lift the ceiling height, we might be able to put the fan, we might have more stratification space for summertime cooling, we might increase people's well-being. There's statistical evidence that people, when there is a taller ceiling height, they believe they have more desk space, for example. Their actual space is more generous. But also, when we increase the ceiling height, we also increase embodied carbon. So how do we balance all of these different factors? One of the things that I was really intrigued by is that this project has this added dimension that you have gone and looked at the actual occupant experience and post-occupancy evaluation on as many projects as you could. I believe you couldn't do it on all of them. But one of the things that, when I was looking at the slides, made me think there's a lot of technology in these buildings. So I wondered if I could maybe ask Andrea, what engagement is required from the users, and how can that be designed into the building so that it compels the correct operation? And what do you think the interface design needs to be for that to work a lot more seamlessly in the future? How could we design all this technology into the building? And what's the feedback?
Okay. So I'm not an expert on this kind of technologies, but I can be a user. And my experience recently is that with my app was telling me that my house in the mountain was perfectly working and I could go there and it was warming up and I went there and everything was cold. So there should be really something that make things really seamless and foolproof. I mean, there is so many things that can go wrong in all the steps from the app to the actual functioning of the house that can go wrong. So there should be safeguards to make sure that all the things are really double checked and connected in a way that the user get the right signal, first of all. Okay, and I think we are still working on that. And second, there is also the need to make people understand what this kind of houses can do. And I was really thinking about it when you mentioned that post evaluation of users, having some testimonial from people living, like having interviews published and people willing to talk about this. That could be a good way to have people talking in a simple way about what you can expect from this kind of houses. So I think, I mean, using the actual experience of people living in this kind of building could be helpful for other people to understand that it's really a change.
So thank you for saying that. I really wonder, so I think what you're saying is that we need a much better feedback loop between the end product and the design cycles.
And the people.
And very much on the people.
Yeah.
But also the performance. Like, Roberto, how hard was it to get all of this user and operational data out of the project?
Yeah, I would say we just started because, as explained also in the morning, I mean, the timing for the construction and design and construction was pretty much longer than planned because of many things, including COVID in between. So we just started and we planned all the post-occupancy evaluation. So we prepared this service for the users and mainly related to their perception of the quality of the environment, as I said before. And of course, this is also connected with the technology. So we are not asking directly how it is the interface with a system or a device or I don't know what, but I mean, which is your perception of the conditions from thermal point of view, the lighting, the indoor soundscape, and so on and so forth. So it is an indirect measure of the quality of what we did. And I mean, I do hope this will become something continuously done. I mean, and then go into the life of the building for a while, and being just a starting point, and so creating sort of, I don't know, common and accessible repository to be visit, to take data in order to be elaborated and to be replicated. So we are working in order to make standard this post-occupancy evaluation that is not usual, even if there are, you know, protocols and blah, blah, but the most of the time, I mean, when you deliver a building, that's it, and then there's some other people taking care of the operative phase. But we would like to connect what we thought, what we designed, what we built, what the operational phase. So collecting the perception of who is living in the buildings.
So again, super interesting feedback, because it is not the first project that when it ends, the post-occupancy evaluation is the aspect that has been delayed and not possible to complete due to the constraints. And
we will do.
Strangely enough, I'm really looking forward to it. Strangely enough, in live projects, it's exactly the same. So once the project is completed, we often take the photographs, and the users are desperate to get into the buildings. They don't want to know about further questions. They just want to get on with the use of the building. I wonder if I could ask Pau, because the energy performance of buildings directly has changed a lot in the last year or so, and there have been some minor changes around the verification of performance as well, sort of hidden in the small print. I wonder if you could say perhaps anything around the hopes for the Energy Performance of Buildings Directive instigating more of these feedback cycles in projects, so we can really accelerate the innovation cycles.
One of the things we have identified, I'm not sure if you can hear me. Yeah, okay. Very close. Okay. So one of the things we have identified for a long time, and I'm very sorry to say this, but the construction industry is not exactly the best example in terms of quality. I'm sorry. I worked as a mechanical engineer designing buildings, and I know what goes on site. So I'm sorry. It's not always the best, and usually when you go on site after the building is constructed, there are a lot of very small things. Either the lights don't come out, or the heating doesn't switch on, or it doesn't switch on the correct time, so the heating is not up to the correct value, or there is a gas leak. I've seen all of these situations. So we recognize that there is an issue there to be addressed, and indeed there is something in the EPBD that now is looking at this. It's a bit hidden. It's an article, I think, 23 or 24, the one on inspections, and it specifically calls on member states to put measures in place, be it inspection schemes or some sort of alternative measures that could be questionnaires, it could be meter readings, it could be any kind of methodology that looks at what's the performance of the building after construction or major renovation, and make sure that it complies with what it's supposed to be doing. And that affects the user perspective, but it also affects the fact that a building is supposed to comply with minimum energy performance requirements. So it checks both aspects. What will come out of it, we still don't know. Member states are working on it. There is plenty of experience in projects dealing with it, and we're hoping to get something good. But indeed, it's kind of a small but very important part.
Hello? Yeah. There is another line somewhere which looks at the databases, and that it requires member states to begin to collect operational data alongside EPC ratings, so compile these national databases about energy performance. There is flexibility in there as well of interpretation, but I've noticed the line in the DVD, and thank you. We have been lobbying hard for it. So I wondered what you feel is the possibility for these measures to begin to inform. So in terms of the guidance of the Commission, so there are some deadlines coming up about issuing the guidance, there are some delegated acts being developed. Is this going to take, is the topics that we discussed here today, are they going to feature in some of this guidance, in particular around recommendations for verification, for collecting operational data and for improving these feedback loops between?
It's because on Monday and Tuesday we have a meeting with member states to discuss these topics and exactly what goes on the guidance. So we will see. I can tell you that it is something that we are discussing with member states, and they're asking us questions on legal interpretation, and we're asking them, and I'm asking you too, for examples on best practice, if you have any experience of things that have worked or things that have not worked, preferably something that can be easily implemented. But yeah, it is something that we are discussing at the moment with member states. Whether it will feature on the guidance or not, that is to be seen. But
and what will be the criteria for including things in the guidance, I wonder?
It's a matter of space, if we have sufficient space on the guidance or not, because there are limits on what we can write. It depends also on the interest of member states to have these featured in the guidance or not. However, I would also say, in order to prepare the guidance, we have held 5 or 6 meetings with member states, a large number of bilateral meetings with member states. So we have held meetings with them in the context of the committee meeting, also in the context of a concerted action, and then lots of bilateral meetings and lots of exchanges via email, also with stakeholders. The value is not so much on the final product of the guidance. That's what gets written in a way, and that's what's most visible. But the real value is in the discussions that we have with, especially with member states. When they ask us the questions and we provide an answer and we have a discussion with them, that's really what influences their work to prepare the transposition. The guidance will come published by June, end of June 2025. By that time, member states will already have had to start the transposition process. So the design decisions for the transposition process are taking place now. The guidance is not going to influence that process. The process to prepare the guidance is influencing their design process, so to speak. So what is important is that we're discussing about it, not so much that it's written.
And are you working on the global warming potential of the buildings, the guidance on that as well, or just operational?
Pretty much every single aspect of the directive. I think every single article is being discussed.
You have an easy life. Eleftherios, so from your perspective, looking at lots of interesting projects and research in this area, what's your perspective on what else is emerging in terms of incorporating technology at various stages of the building's life? So in the design stages, building digital twins, looking at from BIM to digital twin, to then how the building is run, and all this technology that we are putting into buildings, how well they perform in use, what is their life cycle, how quickly do we have to update them, swap them, what's the cost of all of this?
Well, luckily for you, I think there is a lot of room for improvement in the sector, and I think if we compare it with other sectors, in terms of technology, it's lagging behind. So in Horizon 2020 before, from where culturally came, and now in Horizon Europe, we are funding all kinds of aspects from the design phase all the way to construction. We have projects, for example, to robotics, 3D printing, and so on. So to completely, let's say, revolutionize the way we build. The sector is facing several challenges, a shortage of workforce. It's a very accident-prone sector, so with technologies like these, such problems could be solved. We're developing technologies that for during the operation for smart buildings and so on. So we are looking in the whole lifetime of the project, also aspects of circularity, demolition, how to process and reuse the demolition waste and so on. So I think the sector is quite well, let's say, covered and in all aspects of it.
And where do you think net zero plus energy buildings stand within this scope?
Well, I think it's well established. I think it's a matter that has attention, and I think that we will see more and more topics related to it, because at the end this is the ultimate target where we want to reach. I think this is the future, and this is where the topics and projects should aim for.
So Victoria, I come to you because you have been looking at taxonomy and ESG drivers, and it's a really big question. What do we need to see in these areas and other policy initiatives that would help the acceleration of this transformation?
Yes, I would like to link the EU taxonomy with for a project to be considered sustainable, according for new construction to be EU taxonomy compliant, it has to be 10% like less primary energy consumption than NZEB. While the new minimum requirement in a few days will be ZEB, which is exactly that. So basically, in a couple of years, all the new construction will automatically be EU taxonomy compliant. So the issue that we see that the taxonomy is a bit lagging behind the EPBD. So we have very ambitious minimum requirements. But there is, if some investors are investing in positive energy and plus energy buildings in more sustainable projects than the business as usual or minimum requirements, there is no acknowledgement in that to access cheaper finance. So, but coming back to the previous discussion on what are the multiple benefits that both the residents have and the societal have. I have a slide here because we developed a similar approach, but we developed a multiple benefit tool in Synikia project to actually monitor, because for residents, it's not only about indoor environmental quality and comfort, it's also about their health benefits, so they can have less asthma or other diseases. Their their real estate value increases. They can rent out easier the building. There's less vacancy risk. So all these multiple benefits, we quantify and monetize them to account for the cost-benefit analysis, so to build the business case for for plus energy buildings or neighborhoods, because there are also societal benefits like all the grid, like flexibility services to the grid stability, lesser investments to the grid. So all of this should be acknowledged in ESG finance. So all this finance that acknowledges the social and environmental co-benefits of projects. But we still lack really concrete tools and frameworks for the financial sector to differentiate from very ambitious and sustainable buildings and projects compared to business as usual. And I know that the Commission is working on, is planning to work to update the EU taxonomy, so that will also maybe contribute, but it's currently like it's still now working for really pushing finance for really sustainable projects. And another aspect, what I would like to say, that the EU taxonomy will depend on the implementation of the PBD, also in terms of the ambition of zero emission buildings. So how member states will transpose the minimum requirements, because we know that now there are big differences in countries with nearly zero energy buildings. The same or even worse can happen with zero emission transposition, zero emission building transposition. So because the plus energy buildings, according to the PBD, are those that are 20% better than the ZEB. So the good thing that the PBD added to the energy performance certificate a new label that is A+. It's optional for member states to include it, but already having this label that is linked with the definition of the A label, that is zero emission buildings, can push again the market. Like there is a lot of potential in the directive, but a lot of depends again on the ambition of the member states to have like ambition zero emission buildings and to add this extra label on their certificate and the energy performance certificate. Why it's important? Because once you have this label, you will count how many positive energy buildings you have on the market. So something that you measure, you can have policies to push forward and advance.
Excellent. Maybe it's worth going back to William this time again to ask, do you feel that currently there is a business case for social housing to implement some of these technologies, or what do you think is needed on the ground?
There is, in my opinion, there's a need of more positive energy buildings, but the Flemish government, they don't provide any loans or money for that. So when we have some ambition as a social housing company, we have to pay it our own. And that's pretty, because we have a lot of challenges and we don't have a lot of money. So we have to choose our battles. And in my opinion, I try to get in our company that when we are doing a job, we do it first time right. That means if we do a renovation, we do it 2050 proof at this moment. But the government don't give us any money for that. So it's a struggle, that's for sure. But we don't have the time to do things twice or 3 times till 2050. So let's make the right choices and let's go on. But it's a difficult exercise at this moment. That's for sure. It's certainly not clear for us. It's an ambition that we do it on our own. But yeah, what I heard, energy performance guarantee is one of the projects that I worked on, and I see a lot of strange things happening there between the theoretically and the real performance. But what are we doing? We are using the E-label, the theoretically E-label, to determine our investments, our strategy, but we see that that's the wrong way. We have to measure what we are doing, and we have to measure what we did, because we did a promise to our tenants. They are paying more for a positive energy building, they are paying more rent. So we did a promise, and we have to make that true. And that's yeah, that's something we have to work on. That's for sure.
Yes, of course. The projects that you see, because you do have an oversight of a lot of different projects. What are the things that are emerging that would help people make this feedback loop smoother, from design and calculated performance to in-use performance, and be clear with the metrics, clearer with the metrics?
Most of my projects are related to smart buildings, smart components, and relevant technologies. And if you happen to be one of the beneficiaries of mine, always expect questions like this in a review meeting, like how much is the usage of your technology from the end users? Because many times we see that, let's say, enthusiastic users, they use the technology at the beginning, and then suddenly the usage is declining. Or whether they are developing trainings and manuals for the developed technology, because not everyone is expert on smart components, on buildings, and so on. And we always have to keep in mind and design and develop technologies for, let's say, the least educated, or let's say the least capable person of understanding this. Everyone has to use it, the elderly, the disabled person, and so on. So always clear manuals, instructions, trainings are always useful. So these things have to come together with developing a technology in order to be a successful system.
And you might all have experience in this, so I'm just wondering whether there are any new ownership structures emerging that involve the custody of technology in buildings. So, for example, leasing an MVHR or a heat pump for 10 years, and then you just get the next one automatically. That, apart from Energy Sprong, which does look after the operational energy consumption of buildings over there at a specific period, I'm wondering actually about the technology, because this project has explored a huge range of different technologies and systems. Did any of this come up in the conversations, or do you have something on your radar, Victoria, about this, or you, Eleftherios?
Well, there were ideas where, for example, like an app where you can share some kind of equipment. You have a lawnmower. You use it maybe once per week, once per 2 weeks, so then a neighbor can use it. And then not every house needs a lawnmower or a drilling machine and so on. And then you can share, and then maybe even have some kind of, like, let's say, incentive to share your equipment by, let's say, renting it so for a small amount, so that then you get back something. So there are things like this, and I think overall, also we see it in real life, not in projects, like with car sharing. For example, Brussels, I think it's a great example. We have a lot of car sharing applications, and I think in general, people are changing towards that direction.
It's really interesting, because one of a really big barrier that keeps coming up in the EU is the multi-ownership of residential properties, that makes it really difficult to renovate buildings. And I wondered, Paul, whether there is anything in your field of vision that might help overcome that aspect in particular.
No, here we are seeing it's in the guidance.
Yes.
There is a couple, so basically in the EPBD, one of the requirements to member states is to look into the ownership structure and see how, for multi-residential buildings, that can be simplified and make much more flexible. Because in a lot of member states, you need full anonymity of building owners in order to carry out renovation. So there what we see is in a few member states, they are reducing the requirements, so they go down to 50%. One example that I found quite interesting, and I don't know exactly the details, so I'm sorry if I got something wrong, but it's in Spain, and I found it quite interesting because a a building can start renovation works with 1/3 of the votes. And then, so for example, they could install PV panels with 1/3 of the votes. Well, before it would need full unanimity. Then only those that voted and only those ones that paid for get the benefits of the installation. If afterwards one of the other neighbors, once the works have started or once the project of design has started, they want to join in, they can pay a proportional part and also get some of the benefits afterwards. So I thought that option of reducing quite substantially the threshold of votes required, but also who can then benefit. It's not always straightforward. I mean, if we change the boiler, everybody benefits from it. If we insulate the whole facade, everybody benefits from it. But at least it's a start on the process. And I think this approach of like, okay, we don't need full unanimity. We can carry on those that want to, but only those ones that want to then benefit. I also think it's quite interesting.
Yeah, maybe just I would like to add a comment on the previous question related to possible business approach, and we in the project we also studied different way to manage between landlord, users, and energy provider, and exploring different combinations, and you did that. So we also explored the sort of building as a service to give a general definition approach. So this is, of course, this is valuable for rented building, and not, for multi property building. But I mean, there are, to me, a lot to be still explored.
Yes, coming back to your question and what you said, like who invests in the PV and who benefits. I think there was in the morning a nice example that they wanted to use the roofs of nearby buildings because there was limited roof area. We had a bit the opposite case in one of our demos in Sinica. So one of the social housing installed PVs and they had excess of electricity. And they wanted to share it with the hospital nearby because also the consumption patterns are very complementary. But here's the issue a bit with the Renewable Energy Directive. Because there are two ways to share energy. There is with the collective self-consumption, which is theoretically made for residents of one apartment building, that they invest and they all can benefit without being registered as a renewable energy, without being a legal entity. But in Spain, they extended this to 2 kilometers. So they could share energy with these two buildings, but the same directive says that you cannot have profits, you cannot sell energy. So the social housing couldn't sell to the hospital. So what they did was they did a lease contract because they said, okay, we made the investment of the PV, you pay us back over so many years, and then like this monthly payment is a bit like paying for their consumption. But it's a major limitation because also another way of sharing energy is within renewable energy communities, that you do set up a legal entity is more hassle. But even that in the directive, it says you cannot make profits, which was translated as you cannot sell energy. What I see is only those who are rich enough to be able to invest, those are the ones who can benefit, because you can only assign shares from the PVs. But what happens with the more lower
Yeah, no, sorry, you touched on something, sorry, I jumped into it, but you touched on something that is very relevant that I forgot to mention. The delicate issue when we talk on ownership structures is sometimes people don't want to join into a project, sometimes people can't afford to join into a project, and that's really delicate. So all of that needs to be accompanied with a structure that facilitates access to private finance, and when necessary also subsidies or grants, because otherwise a lot of people will be left behind. So you touched on a very good point.
If I'm not mistaken, in Brussels, when you buy, let's say, an apartment, you are informed about the amount that you have to, let's say, chip in a pool of money for the building. So you are informed, okay, you have to pay taxes to the state, but you also have to, let's say, contribute to the pool of money that goes to the building. It will go for maintenance, like the elevator breaks down and so on, but it goes also to investing in the building. So they gather an amount from this that all the apartments contribute, and then they say, okay, we renovate the insulation in the roof, for example. So then, when you're buying, you have to keep in mind that you have to pay. There is no option of avoiding it. So then, let's say somehow the funding is secured, and then I think it's a matter of the group decision of where this money should be invested.
So my next question was actually going to be one of the key recommendations of this project is that we need a better legal framework for the trading of energy surpluses. And in fact, there were some other key recommendations, so about supporting the upskilling, or in some ways supporting the UX design aspects of these technologies. How do we do that? I mean, does anyone have a tip for how we can improve the user interface and user experience design of the technologies and the integration of these technologies in an architectural way in buildings? Or
Yeah, at this moment, as an architect, you have a very important place I'm here today as also a little bit of the client who's letting design the building. We learned that if you want to go to a positive energy building or an NZEP or what else, you have to start a little bit with the energy system and you are building around it. But because it's very well insulated, yeah, you have to take overheating and everything in plus. So the design is crucial at this moment. That's very important. Second thing we learned is that the energy system in Open Lab, a project where Victoria is involved too, in Access, the systems are talking a lot of different languages. In Access, it's are 11 languages, and we hacked some hardware and some software because we can't manage them. And at this moment, we are writing some tender stuff to get in the tendering the right issues, measurements that we need. And we are going to break it a little bit open, so every single design has to call or has to talk with our systems. And that's one of the issues at this moment we are trying to get, but otherwise we don't get where we want to go.
Yeah, maybe a small point again from Culturally, we develop home guides, so sort of instructions for the final users, and the building owners decided to use different approach, from app to very long paper book to kind of highlights and very synthetic information related to how we design it in a way and how to manage the building in winter, in summer, because I mean, as we also listening this morning, there is not only the winter period, but also the summer period, and we have to take into account that in particular when we define the level of insulation, for example, or this kind of thing. So we try to provide all the information to the users. Don't know if will be successful and actually use it, but I mean, that's kind of thing that we would like to ask for feedback.
Yeah, I don't know if this is the moment, but I was starting talking about policies basically. So I came across a couple of slides, I don't know, from the EEA, European Environmental Agency, that may give you some idea about where work in terms of next policies, the sense that you see this is a consumption, the variation in consumption in buildings, which now are 34% of the total emissions. Sorry, these are emissions, not consumption, total emissions, and the variation in the last 20 years. They are 35% of the emissions of the EU, and they decline totally of 34%. Strange combination of numbers, but the interesting thing is that what you get from energy use has declined significantly. What you got from embedded emissions in the design of the houses, so which is the fossil fuel used to build the buildings, is pretty much stable. So there is something to work out in terms of design of the buildings much more intensively than working on how you use the building. So there is still room to improve there, but there is a lot to be done there. And there where it comes, I mean, your work as architects and technology people to do these things better. Another thing that I noticed is that this changed a lot in terms of what is done. So the situation is very varied across Europe, and there are places where there's been achieving an impressive reduction of emissions in buildings, others which are more kind of stable. And one thing, I mean, probably the local situation, what can you do with your building stock has to be a certain case by case in various nations. So perhaps it's easier to change the situation in places where it's easier to build new buildings rather than having to cope with a lot of old buildings which have historical values. So these are, I mean, we should also reflect on how different Europe is in terms of what you can do and where you can do it. Yeah, I just wanted to give some general thought about this and where to act. And a third thought was about this importance of getting the energy from one building to another. So the key point there probably is to start thinking at the neighborhood as the main unit of policy in that case, rather than the building itself. The building is a necessary ingredient, but if you can really exploit all the synergies at the neighborhood level, and you let the legislation allow you to do that, that probably you get a lot of economies of scale and economy of and efficiency from those synergies that are still untapped. Okay.
So I think we have to round up the conversation. It's really time, and you have all been really patient listening. And there were a few takeaways from this project in the context of plus energy buildings. And so one of them was the better legal framework for trading of energy surpluses. There was the role of skill and the role of UX design in these projects. Then the importance of the disclosure of building energy performance data and making that really seamless and routine in pretty much all the projects, how much that would really help, and how the common metrics would support that, and the collection also of occupant feedback collection. And what you emphasized just now, Andrea, was the looking at these projects at the district level. But I'm actually going to finish on the human story, if you excuse me, because I think one of the things that we talked about earlier with Anna Maria and Roberto was how many amazing stories have come up out of this project that describe the real on-the-ground barriers of their success. And I think you touched on this as well, William. What people actually end up doing with all of these technologies. And I think we agreed towards the end, we had a heated debate, but we agreed in the end that certainly there is the onus on all the professions, including architects and engineers, to work with clients much closer and policymakers much closer so that we can begin to really design for these real stories on the ground. And just to finish, I wanted to again draw your attention to this amazing building, which is also a Plus Energy building. And Sabine was the designer for, and she very kindly took us around the project before, and so we have to thank you, and thank you for coming and joining us. Well, thank you for staying. And I wanted to introduce the architect from the building from Norway, who very kindly joined us, and also perhaps Jutta Kastner, who very kindly joined us from DG Culture, who is looking after a lot of the cultural benefits of some of these projects, and also pushing us as the Architects Council of Europe to try and integrate these amazing initiatives into designs that really work for us and for the planet. On that note, thank you so much and see you soon. Congratulations on the project.